today's event. Thank you.
मैत्रीं भजत किल हृजयतीं मैत्रीं भजत किल हृजयतीं मैत्रीं भजत किल हृजयतीम् आत्मवधेव परानपि पश्यत आत्मवदेव परानपि पश्यत युद्धं त्यजत स्पर्धां त्यजत युद्धं त्यजत स्पर्धां त्यजत त्यजत परेषु क्रममाक्रमणम् त्यजत परेषु क्रममाक्रमणम् मैत्रीं भजत किल हृजयतीं मैत्रीं भजत किल हृजयतीं जननी पृथ्वी कामदुगाते जननी पृथ्वी कामदुगाते जनको देवग सकल दयालु दाम्य दत्त दयत्वं जनता दाम्य दत्त दयत्वं जनता श्रेयो भूय सकलजनानां श्रेयो भूय सकलजनानां श्रेयो भूय सकलजनानां श्रेयो भूय सकलजनानां श्रेयो भूय सकलजनानां
Thank you, Madhumita. I invite the student chairman Ramachandran to talk about the Beats Association of Shastra.
Yeah, a very good morning to one and all gathered here. I am pleased to be here today to deliver the welcome address for our department conference Best Bioelectronic System and Smart Technology. Let's me begin with a quick introduction to our department. The Department of Bioengineering was established under the School of Chemical and Biotechnology in the year 2012 with its undergraduate course in bioengineering. To notch things up, the Center for Nanotechnology and Advanced Biomaterial was founded in the year 2005, which further led to the establishment of regular integrated postgraduate course in medical and technology in 2007. Our department aims on developing skills and knowledge beyond the walls of our classroom, and academic lab activities at college really go a long way in helping us explore more and realize those skills. In that aspect, I guess all of us must really thank to our senior Mr. Chandan Mittal, who started the bioengineering at Shastra Association with just 10 members. Since then, the association has evolved and has grown to encompass about 200 active members now. Apart from part of the association activities, organizing national level sympathetic symposia and seminars about various fields in bioengineering. Magis Parma, the department's very own national level conference, has been conducted annually since 2014 on diverse topics, including forensics, neuroscience and neural engineering, prosthetics, next generation device, stem cell biology, medical genetics, to name a few. This time we came up with a new theme focusing on bioelectronic application for precise diagnosis and treatment. Apart from the early seminars, Beats Association also organizes Nano Forum, where young minds come together every week to discuss and enable knowledge transfer about the current trends and various development in the field of bioengineering. In addition, we also publish in-house magazine annually called Envivo, which over the years are revolved in several themes like bio-inspired design, photobiology, water. This year, the magazine is centered in the fourth dimension time. The infrastructure of the department includes newly established biomedical mechanics lab and upgraded biomedical instrumentation lab with ultrasound and CT scanning equipment customized for academic use along with other academic research labs. The department predominantly works on several interdisciplinary fields such as tissue engineering, biomaterials, electrophysiology, drug delivery system, biosensor, to name a few. The department also takes pride in our state-of-art 3D printer laser named Srishti. We are also glad to announce that the members of our department sincerely take part in international competition and fellowships such as Internationally Genetic Engineer Mission, IGEN, Corona Fellowship, MITEC Fellowship. And of course, this goes without saying none of this would have been possible without our beloved Dr. Uma Maheshwari ma'am, Dean Shastra, Arts, Science and Humanities. She has been our constant source of support and cheering guidance, fueling us with motivation and immense knowledge, and also making sure we are going with the right back in all aspects. It's my pleasure to welcome and be in the presence of a esteemed panel of guest speakers, my beloved professor and friends. I cannot wait to listen all the speakers' wonderful talks that will be ensuing sometimes. On the happy note, yes, my big warm hearty welcome to everyone present here for this year edition of our department conference, Best the Bioelectronic System and Smart Technology. Thank you.
Thank you, Ramachandran, for highlighting what our association entails. Now I invite our General Secretary, Gopika, to brief us about the theme BEST.
Good morning, everyone. The theme chosen for the National Conference 2021 is Bioelectronic Application for Precise Diagnosis and Treatment. The conference titled BEST, Bioelectronic System and Smart Technology. The last decade has witnessed a significant development in the field of electronics in healthcare. This has enabled us to reach greater heights in medicine and provide a better lifestyle for the citizens of the world. Improvements in wearable technology has proved us helpful in a way that we have healthcare at our fingertips. An amalgam of electronics and medical sciences has led to the development and evaluation of prosthetics, instrumentation, information systems, and healthcare delivery. In this era of digitization and informatization, smart technology is certainly a breakthrough, shifting us from disease-centered care to patient-centered care. We have the best in the field to take us through a knowledgeable ride on how bioelectronic systems and smart technology has improved the efficiency of healthcare management. Hope you all enjoy. Thank you.
Thank you, Gopika, for shedding light behind the concept of the theme of this year's conference. Now I request Dr. Uma Maheshwari to say some few words.
Dear students and faculty colleagues and all other participants who are joining us online, good morning and welcome to this year's National Conference. Every year I have the pleasure of interacting with the expert speakers who come visit us to deliver these special talks. This is a conference, as was mentioned by Ramachandran, that is one of the flagship initiatives of the bioengineers at Shastra, the Student Association of Bioengineers and Medical Technologies students. And it is an out-and-out student endeavor where they select the theme, they invite the speakers, and there is a lot of planning behind the screens that happen. And finally, it all fructifies into one very, very successful event. And this had been the tradition over the past years. And as Ramachandran had mentioned, actually I was going into a flashback mode when I remember having participated in the very first conference hosted by the bioengineers. There were 10 people, but as Rajnikant would probably say, each one of them equaled 100 persons. And it was such a successful conference, and it was so meticulously organized that it actually sent benchmarks not just for other student associations, but also for us, faculty who also periodically organize conferences, so the kind of teamwork that was exhibited at that point of time by Chandan Mittal and his team was exemplary. And the legacy has actually transferred every year. The bioengineers, regardless of the year, that is one time where I enjoy watching them all making all those plans. And the second year is the third years, the fourth years, and then ever since the medical nanotechnology has been introduced, the fifth years, they all have come together, each one giving their suggestions, and finally the benchmark has kept on rising for the next batch to follow. This year, I would say the past year had been really a challenging one for all of us throughout the world. where the lockdown and the pandemic and the health scare that is still prevalent has confined all of us into the home. And it indeed was a very depressing scenario, but our bioengineers are very resilient. We actually had this chat over an online platform, over a Google Meet, as we decided that we will go ahead with our tradition of hosting these conference. And it has been a new paradigm for us to actually try to work to do all those organization. We all rely on seeing each other, working together, making all those efforts to have, and there is a sumptuous lunch menu that is always characteristic of all these conferences. And there is a poster content contest that happens. There are oral contests that happens, but we have to actually try to bring that onto a digital platform without truly losing the essence of the entire event. And I must say that I was initially skeptical as to how this is going to happen with all of us sitting in different cities, different locations. And I think I am amazed. And I should say kudos to all the bioengineers and of course the mentors who have managed to virtually connect and still bring out the same efficiency and organization skills that are very a hallmark of these conferences. The teamwork continues, and I think the results are showing. I'm really proud of all of these children. They have really done a very commendable job here, and I hope that all the sessions they have put together a wonderful session. All the four of them are very interesting and intriguing. I'm sure all of us are going to be inspired by the experience of the experts who are going to talk. And I think there are also going to be a virtual launch of their magazine. I had a brief preview of what is the content there, and I'm again very, very impressed by the articulation and the kind of information on the theme chosen for the In Vivo magazine, which I'm not going to reveal now. I'm sure the students are eager to do that, but I think I should mention here that it is really very commendable. Thank you for having kept the flag flying so high. And I think it has been a learning experience. Technology glitches notwithstanding, I'm sure this conference is going to be a success. And this has actually given us one more opportunity to explore a new domain of hosting conferences on an online platform. So my best wishes to the team, and congratulations once again for this wonderful theme thought out. And also thanks to all those speakers who have readily agreed to address the students, even though it is a Sunday. So best wishes and thank you very much.
Thank you, ma'am, for your constant support, guidance, and your enlightening words. Now I request Dr. Noel to address the gathering.
Respectively, honorable speakers, faculty members, and students, it is a moment of great privilege and honor for me to extend a hearty welcome to all of you today at this online national seminar titled Bioelectronic System and Smart Technology. Okay, especially I welcome all the eminent speakers from all over the country gathered here to share their knowledge and vast experience with the student community. So since 2014 onwards, thematic national conferences have been organized by the bioengineering students annually. However, due to the COVID-19 pandemic, this is the first national level seminar organized by bioengineering students in the history of the Department of Bioengineering, which is completely conducted on a digital platform in line with the social distancing. Okay, so the main outcome of this one-day national seminar is to bring you recent developments in the field of bioelectronics in healthcare. I hope this one-day national seminar would help students expand their mental horizon. I am sure you will all enjoy the lectures, and we promise you to make this as a memorable event. I request all the students and participants across the country to make use of the valuable lectures to the best of their abilities. Thank you.
Thank you, sir, for being with us through the process of the seminar and for your kind words. Now, we will inaugurate the conference by lighting Kuthuvilakku.
Ideally, when we are doing a face-to-face, each one of the speakers and the student chairman would probably be lighting each of the faces of the Kuttuvilakku. But I'm very glad that the students have thought about this, and each one of us have lit this Kuttuvilakku as a symbolism of the inauguration of the conference virtually. Congrats. Swati?
Now I invite the chief editor of Invivo to unveil the magazine of this year.
Thank you so much, Swati. I would like to start off by congratulating the juniors for the splendid job on this conference and for carrying forward our tradition with such finesse. For Invivo was created almost a decade ago, and it has since been a platform of science beyond our borders, stimulating readers and opening the doors to a whole new world of ideas, perceptions, applications, and theories. Last year, Invivo boasted interesting articles and case studies, photos, and even art and stories around the theme of water. This year, I'm very pleased to present the 12th edition of the magazine with the theme of time. The cover of this edition of the magazine draws your attention to how the needles of time probe various aspects of our life and of our world. From the pocket watch that was once a symbol of pride and is today a prized antique, with their meticulous gears and designs, to the DNA strands that represent molecular evolution as a result of generation time, and the airplanes, the closest we've come to time machines, this magazine explores it all. The calendar mirrors how some people felt the pandemic extend like honey, while for others, the days flew past. The planets orbiting the watch have caught everyone's attention as we explore life on another planet and the change in time because of gravity. This cover was created by Shruti, and it manages to perfectly capture the essence of the magazine and all it entails. Our magazine is divided into sections with some fascinating articles, a few of which are featured here. Based on the perception of time, the passage of time, case studies, time fiction in biology, and even a creative corner. This cover was designed with utmost care, hand-drawn and digitally colored to pay a nod to all the various articles in the magazine. As an extension of our magazine, Invivo used Instagram for anyone who is interested in science, art, and even fun. Constructing the captions that accompany each post and keeping track of their impact has given us experience in how to communicate science in an easy, understandable, and relaxed, yet informative way. We have over 300 followers, and it's been a wonderful journey developing our page. I'm very thankful to all the authors, photographers, and artists who made their contributions that have added color to this magazine. And as the editor, it was my pleasure to work with an amazing team of authors who made our team, and I'm very grateful to them for their active participation in writing. We as a team feel that this edition would stimulate further examination into this fascinating subject, and we really hope you enjoy our endeavor. Thank you.
Thank you, Harshini and team, for this delightful magazine. The artwork is truly amazing, and I was amazed by every detail it showed. We hope you all also enjoy reading the magazine. Now I invite Subiksha, the head of Nanoforum, to present about the events that happened in the last semester.
Subiksha,
I'm sorry. Nanoforum is a weekly rendezvous hosted by the Beats Association, primarily intended for the students of Sastra. It provides a platform to explore the field of bioengineering in the current world, as well as discover the abundant opportunities in the field. The forum has successfully organized various innovative and interactive sessions for the participants. This year, for the very first time, the forum was established on a virtual platform with the prospect of maximizing it on a global level. The first Nanoforum session began with this inauguration by Dr. K. Uma Maheshwari, Dean of the School of Arts, Science and Humanities. She addressed the participants about bio-inspired technologies and its impact on technological advancements. It was an informative and inspiring talk and helped understand the importance of biology in developing technology. The second session was a debate session where the topic of focus was ethical issues. The participants presented with numerous ethical perspectives associated to various subjects such as abortion, gene editing, medical device hacking, cloning, following which brief discussions were held. The discussion facilitated in acknowledging the vital role of ethical norms in the field of medicine and biomedical technology. The next session was addressed by guest speaker Mr. Sanjay Maurya, CEO and co-founder of Urban Air Labs. He talked about his startup venture, UBreathe, and provided an insight on product designing and marketing. It was a synergistic and interactive session where the participants discussed about the establishment of startups and various career opportunities associated with that. We conducted a case study discussion as our fourth Nanoforum session. The aim of the session was for the participants to analyze a case study based on several distinctive medical conditions. This enabled the students to gain knowledge on different conditions such as post-pneumonectomy syndrome, autobrewery syndrome, and motion blindness. The next session was conducted by Dr. Deepika Guha, Assistant Professor in Research at Sastra, debunked the mysteries of the brain and provided us with an insightful talk on how the human brain works, elucidating concepts like dreams, phantom pain, and brain gender. The session left the participants mystified and curious on how the human brain actually works. The sixth Nanoforum session was the very first icebreaker session organized by the seniors of the School of Chemical and Biotechnology. It was exclusively for the first year students to know more about their ever-growing prestigious school, the on and off campus opportunities, it offers, and about classes. The following session was a poster presentation competition where the students from the second year and third year of the departments of bioengineering and medical nanotechnology indulged actively to present their skillful posters. The posters were evaluated by Mr. Celestine Gerald, Dr. Devi Priya, Dr. Sendil Visag Ambi, and Dr. Noel, and the winners were awarded cash prizes. The final session was an expert talk on skill development and career opportunities. It was addressed by Mr. Ayappadas M., founder and director of Harvey Biomedical. He provided an insight on the opportunities available in the biomedical industry and qualities they expect out of a budding engineer. He stressed on the importance of exposure, good language and communication skills, as well as the knowledge over the subject. And with that, the session was concluded with the students understanding the necessity to be well prepared and well equipped. As a new venture, the Nano Forum hosted its very first podcast series, written and recorded by the students of third year of Bioengineering and Medical Nanotechnology Department. This podcast had COVID-19 as its theme. This was new and an innovative approach to reach the masses with valuable knowledge. The podcast was well received by the listeners and circulated via social media to reach many students and teachers alike.
Thank you, Subiksha, for briefing us about the Nanoforum events happened this year. Now I welcome Mr. Chandan Mittal, the founder of Beats Association, to address the gathering. Welcome, sir.
Good morning, ma'am.
Good morning.
Good morning, ma'am. Long time.
Long time. I think the face and the voice remains the same. The energy remains the same. The hairline has receded.
Thank you, ma'am. I visited Sastra in 2016, but it was unfortunately Sunday on that day, and I could not meet you. Yeah. And currently, I am working in Central University of Punjab, and Professor V.K. Garg, he knows you very well.
Oh, nice. My regards to him.
Yes, ma'am. Yes. So, hello everybody. So, ma'am, who is the audience? They are all our students in bioengineering in Sastra.
We have quite a mixed audience. They're all watching us live on YouTube also. So,
Okay.
apart from Sastra students, we have participants from other universities also.
Okay, ma'am. Okay. So, first of all, I thank you all for inviting me for this auspicious gathering, and I thank Hemlata, my batchmate, in during our BTech days. So, I don't have anything technical to say since it is a technical conference, but all I can say is about my own experiences of graduating from Sastra in bioengineering. So, we were the first batch of bioengineering who got admitted in Sastra in the year 2002 to 2006. And it was a very good learning experience in Sastra. Later on, okay, as usual, I got selected in Infosys, placed in Infosys, and then chose another career option. But Sastra was a very good learning ground. It was a base. So all I can say to the students is, as far as I have learned about the field during graduation and afterwards, students need to have a lot more inclination towards electronics, computers, artificial intelligence, and these kind of things. And as I was discussing with Hemlata, students lack interest in those things, and they are more interested towards biolabs and things like that. Yes, biolabs should continue, and as you are doing, and but I think the future lies more towards the Silicon Valley kind of things, where you can show your expertise and pursue higher studies. And the administration of Sastra is actually very good. When last time I came, I met the Vice Chancellor, Professor Vedanathan Subramaniam, and he is very energetic. And even now, I am connected to him over social media. And students should not have any barriers on their mind. That's what I've learned. They should be ready to read or to go deep into any subject, be it research, be it some bio laws or things like that. Personally, I was always more interested towards medical devices, and even now, sometimes I think about starting a startup on medical equipment, medical devices. Yes, ma'am. I feel like doing it. There's a lot of scope in that, and even in my professional life, sometimes I look to get to serving in Ministry of Health and Family Welfare. Okay, to the students, I would say I'm a civil servant these days, and I am 2014 batch of Indian Civil Account Service. So, and we get an opportunity to serve in various organizations of government. So I was looking to serve. There are a couple of things where biomedical engineering is actually quite useful. Regulatory bodies, developing policy on medical devices, things like that. And in this corona pandemic, there is in fact more demand for anything related to bio. Government has issued a circular last year. Anybody, even if somebody is IPS and he has done MBBS or he or she has done MBBS, even they were asked to join Ministry of Health. So uh, that is what is going on my side. So students should have more exposure. They must start some new ideas, and do not feel as second-class citizens, because biomedical engineering is an upcoming field. You might not see all that paraphernalia of placements and things like that, but it's a field, a promising field where you can be. And ma'am, do we have a way of like giving more exposure to students, industry experience, and do they go somewhere? If you can tell me, yeah.
We have evolved also since you have graduated, I think. Yeah, we do have some of the hospital internships and opportunities for the students. Many of them have grabbed them with both hands. They do get all these fellowships also to go and work. And there are a lot of industries that are also keen to offer internships to candidates through a selection and screening process. Yes, and these opportunities are definitely, the students are also aware of this. And I think one initiative that you and your batchmates had started was these type of platforms where people can interact with experts and also get information. What is the trend, what are the advances in this field, and what are the opportunities in the field. I think has actually been a great motivator. I mean, I could say 1,000 words, I can talk so much, still I may not be able to get the point across.
Ma'am, I would like to share that. That was the next thing I was coming to. Once I got very frustrated. It was in the year 2003. We joined Sastra in 2002, and first and second semester was together with biotechnology students. And in 2000, it was 2004. In 2004 June, I got very in May I got very upset. I wanted to learn something, and there was no way out. We didn't know, since we were the first batch. There was no precedent set in Sastra. So we came to know about that Shri Chitra Tirunal Institute and the Chitra valve that they created. So I just went to Trivandrum. I took a train from Thanjavur and went to Trivandrum, and through some personal contacts, met the people in Shri Chitra Tirunal, and they gave us access to their labs and their library, and I read a lot. It was me and BV Anand, both of us went there. Both of us were there for around 21 days, and we discussed a lot of things with people. We didn't know anything actually. We were just going and asking. Curiosity was there, but we read a lot. We studied a lot on those 21 days. We thought it is a very good opportunity. So we read so much that I somehow became. I used to call myself an expert on the knowledge of that valve that TTK produces, Chitra valve. And when we came back, we were happy that we learned a lot, but we were upset also. We didn't know what to do next. Somehow, in the beginning, I was interested in research, but because Sastra's ecosystem is too much research oriented. Mostly, this is what I have learned in South India. This happens, but this is. So I was also in the beginning inclined towards research, but slowly I found no, I'm not meant for research. I need to go into the industry, some practical things. So so we started, and I became member of that Artificial Organs and Biomaterial Society, and we opened a chapter also in Sastra in 2005. And then slowly I thought I must do something in image processing. So I went to Bangalore, Mysore one day, and met L&T guys who were dealing with their. I think L&T is too much into this hospital equipments also. In those days they used to be. So I went there and we asked for a 6 months training in L&T, and they agreed to that. But in the meanwhile, I got placed in Infosys and I never went there. So that happened with me. Sastra management was always very supportive to all the initiatives that we took. We created bioengineers at Sastra Association, and then we started this in vivo thing. So first in vivo editor-in-chief was Meenakshi, and second, I think I did it. So we've always wanted to learn, and ma'am, you had taught us a couple of subjects, and I still remember all that. And anything more specific, ma'am, you want me to say? I can speak on that.
I think it has been a double pleasure to see you. And I think the students, it was a bonus for them to listen from the person who had actually initiated the whole thing. Yes, I think your presence has been really inspiring. And yes, the ecosystem in Shastra was research driven, but now we also moved into the startup domain. So we have a couple of technology business incubators at Shastra. And these are on 3D printing, there is additive manufacturing, and into IoT, the Internet of Things. And the other one is on BioNest, so all bio-inspired technologies. So there are a lot of student startups that have also been there. And during the COVID pandemic time, there have been some interesting outcomes that have actually resulted from some of the prototypes that were being tested at these incubators. So yes, as the years roll on, experience and the networking, knowledge networking, actually has brought about the shift, and it is a very positive thing. I believe even today, the fact that I was listening to all the students' options of nano forums, which were actually a weekly meeting on more face-to-face mode that had actually continued, but on a virtual platform, and they've done a good job. All the poster presentations, contests for the students. So they have found a way out, and the fact that I was also a little worried, how the technology is going to support us for this online platforms really happened. And I think one silver lining of all this pandemic is that we have actually become more innovative and we could improvise a lot. And I think the fact that Chandan is here talking to all of you is also testimony that one positive thing about this online, right? We could join no matter where we are, in which corner of the world. Anant, by the way, had also addressed the students. It was, I think I should thank Hema for bringing in all of those stalwarts. We were looking forward to Meenakshi's talk sometime too. So I'm very happy to hear about the progress. The students, bioengineers, will be definitely benefited by talking more to you. I would place a request on live streaming also, that you people should probably interact with the students. You could be with your experience, you could also guide them as to what are the opportunities that are available beyond what you see is the most obvious, and you are absolutely right. Biomedical engineering has a lot of career prospects, a lot of domains. Awareness is the most important need of the hour, and I think it is there where all of you could really contribute, because you have seen it all, and you are you have done all very well. So I would definitely request you to do that.
Once I was looking for when I left Infosys, I was looking for a good job in government system. I was preparing for civil services in those days, and there was an advertisement by Department of Industry. So that was the first advertisement that I saw somewhere in around 2010, and the eligibility criteria was biomedical engineering. So what they were looking, the role was patents and trademarks and these things. So they were recruiting people from biomedical backgrounds who could work in patents and these things. So that was very good. And then I started reading on WTO. WTO has online courses. You have to study and then appear in exam. They send you certificate. WIPO, World Intellectual Property Organization. So there are very many avenues actually. Students have to see to it what they like and how they want to go about it. So anything, if students want to ask, I mean, there are only 19 participants, or even though it's
You wouldn't see all the entirety, because we didn't want a lot of cacophony. So the participants are seeing it through the YouTube link, and any queries they can post in a chat box, and the moderators would probably be able to ask us through here.
Okay.
Because this is something that we discovered while doing some of the webinars, that if you have all of them there, there is a lot of confusion. Everybody unmutes, and then there is total chaos. So we restrict on the entry into the Zoom platform. I would take this opportunity to also welcome Dr. Parashuram, who is our next speaker for the day, or rather the first speaker for the day. And I think the moderator, I think Swati, can do the honors. You can keep compiling the questions, and you could post it. I'm sure Chandan will join, will continue to remain online to be with us. for some of the sessions. And you could, I'm sure they will have a lot of questions that they would like to ask you. So welcome again in a very informal manner. And
Yes.
over to you, Swati.
Yeah, I understand it is a conference and I turned it into a meeting or a webinar. Yeah, so,
No. I think it added all the most needed inspiration. Over to you, Swati.
Sure, ma'am. Thank you, sir. We'll pass the questions on to you after compiling them via mail. And we are really grateful for this association and the tight bond it has helped us create with our seniors and juniors. Thank you for your presence and your kind words. Now I request Sai Sadanand to introduce our first speaker for this session.
A very pleasant morning to one and all gathered here. I feel immensely happy to invite Dr. S. Parasuraman, Senior Lecturer, School of Engineering in Monash University. He has worked great diligence and effort contributed in the fields of robotics, kinematics, and spine. His literary works include 217 publications and 46 journals. His tree of success incorporates a lot of achievements and undoubtedly yet more to come. He has been honored with Excellence in Research Award in the year 2008, followed by a lot more awards in the consecutive years. He has been elected as the Vice Chairman of IEEE Robotics and Automation Society in the year 2013. Starting his career with a degree in mechanical engineering from Madras University, he now stands with a doctorate in mechanical engineering. Sir, on behalf of the whole crew, it's absolutely a privilege to welcome you. Your knowledge knows no bounds, and I'm very glad that today I would be able to fetch at least of it. Welcome, sir.
The moderator for the session can also please indicate the participants about the mode of asking the questions to.
Students, if you have any questions, kindly drop them on the chat box in the YouTube link, and we will ask the questions.
Hello, good morning, good afternoon here, and good morning day. Sorry, I'm not. Hello, are you seeing?
Yes, sir. We are able to see you and hear you. Welcome.
Okay. Just I want to mute myself. Actually, I told to Kemalada that I'm not well, so just I will once again mute my video.
Sure, sir. Sure, sir. Take care.
Once again. I couldn't mute my video. Are you seeing the screen now?
Yes, sir.
Okay. Hi, good afternoon and good morning. Here the time is 1 hour 32 minutes afternoon in Malaysia. I think as someone introduced me, I'm Parasuraman. My hometown is again back to India, Chidambaram. And I worked in Malaysia as well as in Australia for around 25 years. I did my PhD in Monash University in Australia under robotics. Currently, I'm attaching with another campus which is located in Malaysia as associate professor in mechatronics engineering. And before, I think this is the introduction about me. And my area of research is more towards on robotics, kinematics, and biomedical engineering, more related to human motion analysis. Today, the presentation which was requested by Hemalata is more related to biomedical engineering that I am focusing on the spine. We are currently working on the spine with some partnership in Indian universities. Okay. Actually, this project we started in 2015 in association with the Ministry of Higher Education in Malaysia, as well as the DST project within India, collaborated with the SRM University. We have done almost, we have finished this project. We started in 2015. The title of the project is the kinematics driven finite element model for lumbar spine disc degeneration. Some of the fundamentals, I think this is the problem of everyone facing in elderly or aging while they are achieving aging process. Okay. And generally, this kind of problems, I mean, disc degenerations. Normally, the disc degeneration will degeneration may occur at a lumbar spine. Generally, the human spine segments are cervical, which is located at the just below the head, and then thorax at the middle part of the spine, and lumbar spine is at the bottom, where most of the time experiencing kind of a load patterns. So most of the people will have spine problems when they are in about 70, 80 age, around those time segment. Okay, so you can see the picture which is we just given over here, and I put some kind of circle. Are you hearing me?
Sir, we can't see your PPT. It's not visible. Sorry for the
That's what I asked you. Again, I'm sharing. Are you seeing the screen now?
Yes, sir.
Okay. So this is the screen where I started.
Okay, sir. So it goes offline when you go into full screen mode.
Okay. Again, I'm sharing now. Okay. Once again, let me settle this first. Are you seeing this now? Are you seeing this now?
Yes, sir.
Yeah.
Okay. Then when I change into view mode, it's not disappearing, right?
Yes, sir.
Okay. Now? Is it visible?
No, sir. It isn't visible.
Not visible.
Yes, sir. It isn't visible, sir.
Okay. Yeah. So now it won't be a problem now. You can see here. So now you can see.
Sir, it is not visible, sir.
Okay. Now? Is it visible now?
Yes, sir. It's visible now.
Okay. Now let me go to the slide. Now, is it visible now? All?
Yes, sir.
Yes, sir.
Okay. Then it's okay now. Okay. So you can see the picture here, which is located at the bottom here. See, I put a circle there, and then I drawn the vertical line there. Okay, before that, the main function of the spine is it support weight of the body and then limit the motions. So first one is it support the weight, body weight, and then you can see the limiting the motions. So there are three kind of motions. When you bend down, there is and see there are three kind of motion: axial rotations and abduction, adductions, and then lateral bending left and right. So the three kind of rotations will be limited by the spine. The second one is it is support the body weight. Okay, so now you can see that there is an intervertebral disc which is located between the two segment of the spine. Okay, and so in between the center of the spine or the disc, there is a nucleus. So gel-like material that is called nucleus. Later I will explain to you. Maybe you can see the diagram here, the center of the portions. See the nucleus here. And then the outer portion is called annulus fibrous. Okay. So this will be located between the two spines. So this is now this is called the sacrum and the spine 5, number 5, number 4, number 3, and so on. So between the lumbar or intervertebral cortical bone, there's a disc located. So the disc consists of the nucleus bulbus and then the annulus fibrous materials. Now you can see this is the gel-like materials. Okay, and when there is a load pattern, assume that the total weight of the body will be transmitted between the spine to the disc. Okay, and now when there is a load applied, that should be more symmetric. So when you see here, when the person is standing over here vertically, so now you can see here the body weight is symmetrically applied all around the nucleus and the annulus fibers through the cortical bone. Okay, so the load pattern on the spine is more symmetrical, and you can see the second diagrams. The person is lifting the load, and then you can see the center of gravity. So center of gravity of the body is here. Center of gravity of the load is here. So there is an eccentricity here. So now you can see that in that case, the load pattern of the spine is not symmetrical. Similarly, you can see the other portions over there. For example, this girl is wearing a high heel over there. Okay. Now you can see the center of gravity of the body and center of gravity of So if you draw a triangle on the walking pattern, see, for example, if you draw a polygon of the foot on the ground, see, you can find out the centroidal distance of the polygon, and then the centroidal distance of the polygon must align to the center of gravity of the line. If it is away from the center of gravity of the line, at the centroidal distance of the polygon, then there will be a problem. Unsymmetrical load pattern will occur at the at the spine. Okay, so these are all the reasons that why disc degeneration occur. Okay, I think this diagram will give a clear picture the problem of disc degeneration's possibilities. And normally, when they do the loading by younger people, it won't be an issue. When it is aging occur or the aging process is taking place, generally this kind of disc degeneration is possible. Okay, so the reason for degeneration disc disease is due to the age factor, and then the lifestyle. So maybe the posture, weight pattern that they are carrying, as I had given the diagram the previous slide, and then the genetics. Okay, so those factors will be the external factors, and other factors are material and physical property of the disc changes. So as I mentioned now in the previous slide, so the annulus fibers increase in stiffness. So there must be a flexibility on the annulus fibers. It is because it is a gel-like material. When there is a load occur, when there is a load applied over there, and it should allow the load within the annulus fibers, it should not be fused out, so that the disc height should be maintained all the way. Okay, so these are all the reasons that why disc degeneration occur. You can see the diagram over here. So degenerated, see, you can see when there is a disk with this normal height, this means this is a healthy disk. And see, when there is a disk height is reduced, and then the material, the annulus fibers is fusing out. You can see over here. So this means the disk is degenerated. So it means need to have some kind of attention and remedies for healthy lifestyle. Okay. So the objective here is, the overall objective here for the project is to analyze the lumbar spine by generating a 3D model using CT scan images. Okay. So what we do here, we do the CT scan image from the hospital. We take a CT scan image from the hospital and we convert the CT scan image into the 3D modeling by some kind of techniques. I will explain you the techniques later. Then we do the analysis by using artificial intelligence techniques. So the reason why we are using artificial intelligence techniques is, see, getting a spine specimen is very difficult. So it is a lot of restrictions, and you need to get ethical approval to get the spine, and you can't have the real spine. So due to these reasons, we developed the 3D model from the lumbar spine, which is available through CT scan images. And from the CT scan image, we convert the more subject-specific model. Subject-specific model in the sense, assume that a particular person CT scan is available, and we take the CT scan image, we hide some of the personal details of the subject, and we develop the 3D model, and we do all analysis later. I will explain to you. So what we are doing specifically here, we are developing a FEM model through the CT scan for healthy subject, along with some of the model with the degenerated level. So we do this both. Okay, and we do the stress analysis using the FEM model and determine the impact of severity of the disc on the FSU. FSU in the sense a functional spine unit. One functional spine unit consists of two spine or two cortical bone, cortical bone with spine. That is a disc. I will explain to you FSU. One FSU consists of, for example, lumbar 5, lumbar 4. In between there is a disc, right? So this is called the FSU. And then we do the artificial intelligence techniques. Here I will be explaining later about the fuzzy logic systems for big data development. So by using simulations, we used to get only a limited data set. And from there, we develop the big data set for picture analysis. So this is what we are doing here. Before doing the actual experiment simulations, we do the analysis in vitro, in vivo, in silico, and in vitro analysis is nothing but we are using without invasive method. In vivo, we are doing some invasive kind of studies, and in silico, mostly on simulation patterns. And before going to the analysis part, we have done some kind of literature on each area. And each literature, what we have done, what kind of methods they use on in vivo, in vitro, in silico, and what are their findings and what are their limitations. So we have done literature recently from 2015 until now. And each method, the limitations are highlighted over here and summarized later. Similarly, what kind of artificial intelligence techniques they use to find out the shortcomings on the studies by using fuzzy logic systems, machine learning, and optimization techniques. So out of all this, we come out with some kind of conclusions, what the previous studies missed out and what we are able to develop data. Okay, So the combination of several types of studies to analyze the spine segments, now to accurately simulate load acting on the spine from actual ROM. So the actual ROM is range of motions. As I mentioned, the range of motions are abduction, adduction motions. There is lateral bending left and right, and then the axial rotation. So three range of motions. So the abduction, adduction we used to call the flexion. I will show you the range of motion later. Flexion and extension. So when you are bending downside is flexion, and similarly when we are going backside is extension. Similarly, lateral bending and left and right. So when you turn left and right, so and also the axial rotation. These three kind of range of motions we used to do the analysis. Okay, so this kind of combination of study nobody has done before, and we are combining the range of motions by in vivo, and we are combining the in vivo range of motion experimental studies with in vitro. Okay, so the documenting model related to mesh qualities, when you create the finite element models, the mesh quality index be reorganized with the various patterns, so that will provide the reliability of our models. And then we use the AI techniques. Here we use a fuzzy logic system to predict degenerative disk with this, and analyze the safe level of various spine segments parameters. So this is what we have done, and this is what the research gap that we have done from the previous literature. So that we are going to study now. Okay. And initially we started with L3, L4 lumbar, and later on we come to know that comparing the L3, L4 lumbar spine, L4, L5 is more crucial for degenerative disc. So that's why we want to, our focus is deviated to L4, L5. And we have done one very good publication with the L3, L4 journal with the top 10% journal. There is more than Q1 publications. Now we have done another 2 more publications with this area, L4 and L5 now. So our methods. So what we have done, the input, we have taken the radiographic images. So the radiographic images of the L4, L5 lumbar spine. So you can see our focus is only on this pattern. So the CT scan images just comprises of 490 slices. So 1 mm slice increment. So we extracted the images on three planes: axial, coronal, and sagittal plane. 3 views. After that, after extracting the radiographic images, a CT scan image with these 3 plane, axial and coronal sagittal planes, then we are combining all the 3 images into 3D model by using materials mimic surface. So we applied a threshold, and we put all the threshold over here. And we select the 3 segments. There is this region with the coronal, sagittal, and axial planes, and combine all these 3 plane into a 3-dimensional view. Okay, and we applied all the threshold. Once after getting the radiographic image or the CT scan image in 3-dimensional, we want to remove some of the unwanted bones. So this is more on subject-specific model. This is the model for the particular subject or particular patient. So all the data particulars are hidden due to ethical procedure. So after the extraction of the bone, the spine, what we have done, see, some of the holes will be there, some spike, rough edges. So those would be removed by using GeoMagick. So the surface model obtained from the mimic consists of various artifacts like holes and spikes. So that could be filled by using a manual process, and the tool will allow, the GeoMagick tool will allow to fill up those holes and then remove some of the spikes. So the surface model is further refined manually to produce smooth model using various tools on the GeoMagick. So after refining the model, the spine look like this. Okay, so the completed model is then exported as a STL format for machine. You can see here, and this is L4 and L5. So this is L5. There is number 5 and number 4. And the surface mesh, the triangular elements are used on the surface mesh with the size of 3 mm. So that the cortical layer is created with the thickness of 0.35 mm. And legments are created based on the anatomical procedure and attached with the models. So fine tuning of surface mesh carried out with a certain position of geometry to ensure satisfactory mesh quality. And you can see here the complete picture of the elements. I will explain to you later. Okay, so now you can see here, this is the complete portion of the elements of cortical bone. So now you can see here the outer layer of, and this is the number 5 and number 4. The outer layer is called the cortical bone. That is the hardest material on the spine. And the inner portion is called the cancellous bone, and this is soft material. And you can see here the annulus fibers that I have given in the initial slides. So this is the annulus fibers of the disc and nucleus pulpus of the disc, and then the facet joints. So the function of the facet joint is to limit the range of motion. So I mentioned to you the three kind of range of motion, right? Flexion, extension, and then the lateral bending left and right, and then the last motion is axial rotations. So all three kind of motions will be restricted or limited by using the facet joints. Similarly, the cortical bone and cancellous bone for the lumbar 5. Okay, so this is the complete structure of the L5 and L4 with the various bones. So we will be extracting the stress level of cortical bone, cancellous bone, and nucleus bulbus, and annulus fibers, and face plate. And now you can see that both see the disc and then the lumbar is connected by the face plate over here at the interface between the disc and then the bones. Okay, so this is the complete structure of the vertebral disc and the ligaments. Now the next one is the material properties. See, the material properties for all the cortical bone, cancellous bones. So for example, Young's modulus, Poisson ratio, all of them are done with real experiments. What we have done, we took some kind of spine, human spine, and we have some facilities at SRM University. We have done the spine testing over there. So we have done some of the experimental, for example, we applied the load and we find out all those kind of stress strain relationship. Then we came out with Young's modulus, Poisson ratio, and modulus of rigidity, those kind of data. Okay, so these are all the material properties at all the bone levels: cortical bone, cancellous bone, and then annulus fibers, nucleus pulpus. Okay. Then after that, we have done the FEM analysis. So the loading pattern on FEM. So all forces shown are based on 10 Newton meter moment based loads applied over here. When we do the compression loading, 720 newtons are applied. This is based on, assume that the location of the L4, L5 on the body location. So the total weight of the body is proportionally this load is calculated, and also we refer the literature, and based on that we fix the compression load is 720 and deflection load is 1200, extension is 1000, lateral bending is 1300 Newton, and then the axial rotation is 4000 couple. Okay, so this is the load pattern that we applied. And now you can see here, I mentioned to you, right, we developed about 10 spines, L4, L5 spine with a healthy to see the 8% is almost a healthy spine, and then the 60% is almost a degenerated disc. Okay, so the percentage is given over here, the percentage of degenerations. So 60% of the degeneration means almost the disc is degenerated, and I think more around 30 to 40%, 40 up to 40% is tolerable, and more than 40% is degenerated and need to have attention with clinical treatment, and that could be done by clinicians, not for us. Our attention is only for the analysis and provide the report to the clinicians. Okay, so these are all the experiments that we have done, developed, simulations are developed, and then we have done the simulations. I'll show you the result of simulations later. Then we see the range of motions. What we have done, see the circled one, the simulation, the range of motion experiment we have done from the experiments. So range of motion in the sense, see, we have the facilities, something like, see, motion capturing systems. So sensors called a reflective marker is placed at the spine, outer surface of the spine of the skin of the spine, and then we allow the subject to do the three kind of range of motions. That is called the flexion, extension, and the lateral bending left and right, and the axial rotations. So the circled one is our experiments, and then the rest of the experiments are the previous experiment that they have conducted. So Emamoto is the person who conduct the experiment. He's a well-patterned research materials. Most of them are following Emamoto and White and Punjabi literature. And we also follow the similar kind of literature. So we can put that this is a model for every experimental investigations later on. So we also compare their results and comparing the range of motion over there. So when we did the real experiment with the in vitro studies of range of motion for the flexion extensions, so our range of motion is comparatively better than the previous studies. And for lateral bending left and right also better results, and similarly axial rotations. Now what we have done, so we applied this range of motions to our FEM model. Okay. So we applied this range of motion into our FEM model for flexion extension, lateral bending left and right, and axial rotation. For in vitro, in vivo, in silico, and we can see some of the experiments. So this is our load pattern for both all the, for example, like the first one is axial loading, then left and so bending left and right, then the rotations. So these are all the type of load patterns that we applied over there, and then stress analysis. So now you can see when you apply the load pattern for healthy subjects, Now you can see how the loads are applied, and then the disk degenerations are taking place. So when the color changes to red, see the bottom diagram, when the color changes to red color, it means disks are degenerated more severely, and then the disk heights are reduced much. So moving on to the next one. So what we have done, we extracted the stress level with a percentage of degenerations for all the bones. For example, now you can see here, this is the cortical bone. This is the cortical bone stress level with the percentage of degeneration. I mentioned to you 0 to 60% of degeneration, right? So for 60% of degeneration, we extracted the stress level for cortical bone, cancellous bone, annulus, and then the nucleus bulbus. So the safe stress level is over here for cortical as well as the AF stress, safe stress. So we extracted this data set for 3 cases. So 10% of degenerations, 30% of degenerations, and 60% of degenerations. Okay. So we extracted 30% of degeneration level for stress level at the cortical bone, cancellous bone, and annulus and nucleus bulbus. Similarly for 30% and 60%. So the purpose of extracting this, we want to develop the big data set and develop some kind of design of experiments for further degeneration at various intervals. Okay, and same thing will be extended for extension. Lateral bending left and right, and similarly axial rotations. So we extracted the stress level versus the percentage of degenerations for cortical bone, cancellous bone, annulus, nucleus. Okay, so this data will be used for prediction of DDD for several subjects. What we have done, so we developed a fuzzy logic systems with the 5 inputs and 1 output. The inputs are AF stress, annulus fibrous stress, nucleus bulbous stress, cortical stress, cancellous stress, and disc strain, and the percentage of degeneration is output. So we have generated this kind of fuzzy logic systems, and then the data sets are coded into the linguistic variables, and some of the codes are given over there. And then we develop the rules formed based on the trend seen on previous figures on the graph which I have given over there. The 3 graph for 3 range of motions and related to the cortical bone, cancellous bone, annulus fibers, and disc degenerations. So based on that, we developed the rules. Now you can see here, this is the fuzzy inference systems. So this inference system, the output is degenerated levels. So the inputs are annulus fibrous stress, nucleus fibers, cancellous bone, and then cortical bone stresses, and von Mises strain. So now you can see here, when I move this vertical scale, slide the vertical scale to any level. See, I'm doing only for the fractions. Similarly, we develop for the extensions. and lateral bending left and right. So when we slide the vertical scale to the level of stress at the annulus fibers, nucleus fibers, a cortical bone, cancellous bone, automatically the disc degeneration level will changes. So we can develop any number of data set by using the fuzzy inference systems. So when for example, you can see here again, I will run here the simulations. See, now you can see here the vertical scale. Automatically, the level of degeneration will changes. So I can slide the vertical scale to the any level. Now you can see here cortical bone stress, cancellous bone stress, and cortical bone stress. I'm moving to right side. So automatically you can see that this degeneration changes. So similarly, I can move the vertical scale to any kind of level. So I can find out, for example, if I have the specimen, assume that the disc degeneration is about 20%. What will be the stress level? So I can reverse the systems. So similarly, I can put the disc degeneration as an input, and one of the cortical bone is more crucial one. Cortical bone and annulus fibers are more crucial one. I can make it as output. So I can find out if I have a subject with the degeneration of 20%, what will be the stress level? What could be done for the replacement of either replacement or fusion of the disc? That could be analyzed by using the fuzzy inference systems and provide the advice to the clinicians what could be done for the spine fusion or the replacement or any kind of surgical operations. So this way, this system will be more useful for any kind of subject, any kind of patients in the clinic. So this is the objective over here that we have done by using the AI systems. And automatically, when you have the changes over here, you can see the changes on the output. So my output is like a degenerations. My input, I can change two of them are input. You can see the changes on the diagrams over there. And see, I can extract the data. For flexion extensions, so when I do the changes over here, I can extract what are the stress levels. Okay. So this is the way that we want to conduct. So what I did now, how I want to evaluate the accuracies. So you can see here the red color is a degenerated disc. See, now the actual graph is see the blue color is the actual degenerated level by using the fuzzy inference systems. See, now we have done right. So now we have done the simulations over here. So this is the simulation result, the degeneration levels. So the actual degenerations we have done in the graph. See, now you can see here, this is the actual graph over here, the data set. Okay. So for each motions, axial rotations, or like lateral bending, or extension. So this kind of graph, we can see the actual degeneration levels. After that, I have done the simulations over here. So when you plot the graph between the actual data and the degenerated data, you can see the error is very minimum. So the difference between the actual and the actual degenerated level and then the simulated degenerated level, the error is very minimum. So the percentage of error is 5.8%. That is tolerable. And this system could be used for any kind of big data systems, big data set. So in the sense, so by using this kind of systems, assume that there is a patient come with disc problems. After seeing the radiographic images or the CT scan image, we can predict the height, disc height. So assume that the disc height is around 30% of 30%. So 30% could be converted into the dimension in terms of mm. So when you have that, what will be the cortical bone? Cortical bone stress is the more crucial level. So when you have that, so what will be the remedy? What kind of material could be used for fuse the L4, L5? so that the people can do the normal life for walking or day-to-day life survival. So that could be achievable by using this kind of results. This is what we have done, and this could be this can be used for. This have been using now for a few places in the hospitals for the spine fusions. So this is what I would like to give it to you. Now it is open up for questions. So you can ask me question now.
Thank you, sir, for the wonderful talk. And it was so much insightful about the about us knowing about the cortical and cancellous bone and how we use artificial intelligence to know about these things. And there have been quite a lot of questions in the YouTube chat box. And the first question is there any open source?
Is there any chat questions? I will check the chat.
Yes, sir. There are a lot of questions in the YouTube chat box as well. The Zoom chat box might not have some. But the same
I
meeting.
couldn't see the chat here.
No, sir. But the same meeting is being streamed in YouTube, so a lot of participants are watching it from there, and we have a lot of questions from there too.
Okay.
So the first question goes: is there any open source software other than GeoMagic to obtain the surface model?
There is no, actually, there's no open. You need to, it's a license based. So the institution need to invest to buy those kind of license of the software, and then must try. And if it is open source, it may be a trial versions. So you can try the trial versions of software. And moreover, the CT scan image is a bit difficult. You can't get a CT.
Okay, sir.
CT scan image of the CT scan of this spine. The hospital won't reveal until otherwise if you have some kind of ethical clearance. You won't allow to use it.
Okay, sir. And the follow-up question, the next question is about data collection, the initial step of the whole process. How is the data collected and tested, and what are the components?
When you do the simulations, I think I have shown the simulations, right? So when you apply the load, for example, like the axial rotation, for example, the range of motion axial rotations, we have done the range of motion for axial rotations. So we have the data sets, right? And with the combination of axial rotation, range of motions, and then the combination of load pattern, we apply the load in the finite element model. So once if you apply the model load, then you can automatically extract the data set. You can see the load at each segment. So those are all the load that we are taking for the fuzzy inference systems. So first we have done the simulations by using FEM, and we extracted the data, right? So the data sets are very limited for each range of motions. From there, we develop the data set for AI systems, and by using AI system, we are developing millions of data sets. So just by sliding the vertical scale, you can develop a big data set for any kind of patients. Someone coming with some kind of problem, spine problems, so we can use this data and simulate, and then you can find out what is the problem with a particular subject. Okay.
Okay.
Did I answer for the question?
Yes, sir. I mean, in my opinion, you answered the question. I don't know if the participant has had any other question in their mind.
Okay.
And the other question goes, one project we attempted was to use neural networks to determine the space reduction between kneecaps and rheumatoid arthritis using X-ray images.
Yeah, it could be done. So we will be doing in future. We can use machine learning to find out. We can predict the disc height, disc level, disc pattern, and we can pick the target, and then we can find out. It won't be an issue. We can do that.
Okay, sir. And if a patient is too hefty or had a previous surgery to place rods or screws in their legs and arms through their bones, and the quality of CT images would always be expected to be somewhat degraded, or the quality would be not as much as of a clear CT image. So why CT or MRI cannot be used for any?
Actually, we are now we are working with the CT scan image. We are not going beyond that. So whatever the CT scan, the image that we have, okay. So we are extracting data, and then by using, some of the data we are using by like a real spine, by using the spine testing machines. So that the data will be for extracting the material properties. Okay, and this data, the simulation data, is to find out the range of motions, and then the other data like simulation. I mean, to extract the simulation. See, we are applying this kind of material properties, and then we are using those data which we get from CT scan image. So the material property will be from the real subject, real bone, real spine, and then the experimental simulations are based on the CT scan. The range of motions also with eVTOL.
And
so we are combining all these three areas together.
Okay, sir. And do we have any reason why exactly CT and not any other imaging techniques like?
I couldn't hear you. I couldn't hear you.
Okay, sir. Sorry. Can you hear me now?
Yeah.
So, is there any specific reason why we exactly use CT and not any other imaging technique like MRI or?
Yeah, we can try. We can try. There are people working on this. We worked in this area. So there are people working on those areas. It is still a lot of research are going on there.
Okay, sir. And there are also a lot of follow-up questions. I'll read them also. If the brain is studied with the help of 10 to 20 electrode EEG systems, can the activity of brain be simulated accurately using these softwares?
We are not taking any brain signals. So here what we are using is the reflective marker, which is placed at the skin on the spine. So roughly we locate the spine L5, L4, L3, so up to L1. Then we are extracting the spine motions. We have nothing to do with this brain signal. This is what we are asking, right? Is this your question?
Yes, sir. I mean, this was the question which was asked in the
yeah.
YouTube
we are not extracting anything from brain signal.
And the transition, I mean, there is also a seemingly wide transition from bones to brain.
Again?
I mean, what we are studying so far is related to bones, whereas
related to bone, related to spine, the spine segments.
Yes, sir. And the last question is there any way we can analyze the electrical activity of the spine? How will we be able to differentiate the EMG obtained if we?
We are not using EMG yet. Actually our concern is to find out the disc degenerations. We are not doing any kind of study by using EMG signals. Generally, the EMG signal is the energy level on the muscles would be done, but in this case, not necessary. This is my answer.
Sir, I'm sorry to interrupt you, but it seems that your video isn't visible in the YouTube stream. So can you?
Yeah, I have done a lot of experimental study by using EMG, but rehabilitation systems. This means like we extracted the energy level of, for example, our arms, hand, those kind of area. For example, if you want to move the elbow, then there must be some kind of muscles responsible for the movement of elbow. So we use those kind of EMG, electromyography signals, and then convert them into the amount of force required to move the arm movement or elbow movement. Then we drive the parallel system. We design the parallel mechanism to drive the elbow, those kind of things. But here we are not using any kind of EMG systems. That is for some other purpose.
Okay, sir.
Yeah.
And we have one final question. Since the competition is complex, did you use any type of high-end processor for simulating the whole process?
Not a high-end processor. Not necessary. It's only At the maximum, when you have more number of rules, it takes time sometimes to process the data. For example, in the fuzzy logic system, which I mentioned, if you use more number of input with the more number of fuzzy set, and you need to have good processor. But so far, I don't have any kind of issues. And when you use neural network, yes, you need to have a high-end processor. That you need to find out the requirement. When you have like multi-layer, more hidden layer on the neural network systems, then when you have good algorithms, then really you need to have high-end computer processing. Otherwise, your system will crash, will hang.
Okay, okay, sir. And this is my question. So, apart from AI, can we kind of insert our own inputs into the algorithm, sir? Because we already know that cortical bone. We are comparing stresses and strains between cortical and cancellous bone. We know that cortical bone is somewhat more denser than cancellous bone, since cancellous bone is soft, spongy in nature, and cortical bone is not.
That's
So,
what that's what I use cortical bone stress. See, when you come to the fuzzy inference systems, I mentioned to you, right? Assume that you want to put it percentage of degenerations in the input, cortical bone as output. Okay, and then you can see there is a subject come with some kind of a disability on the spine. Then we can find out, we prepare this kind of inference systems. When you slide the scale, you can see what is the level of cortical bone stress. So cortical bone is the more crucial one. So all the load will be on the cortical bone. From the cortical bone, it is transmitted to the end plate to the annulus bulbus, and then the nucleus bulbus.
and how does the segmentation process differ from?
No, I'm not clear. So not the sound is not
Okay, sir.
audible.
And can I know how does the segmentation process differ from brain and spine, sir?
Brain and spine.
Yes, sir.
No, we are not working on that area.
Okay, sir. I
So
think
it's more complex.
okay, sir. I think that's all other questions from the chat box.
Okay.
So I'll hand over the baton to Sai Sadanand.
Okay, thank you and thank you very much. See you then later. Bye bye. I leave
Thank
now.
you very much for your talk, sir. Your talk instigated us yet again to think about how extensive the field of bioengineering is and how we can apply it in real time. With image processing being more useful with every growing day, its application in your project and in association with the various tools has also given us an inspiration in think broader. Thank you very much for this highly informative session. Thank you, sir.
Thank you, sir, and thank you, Sai. Now we will have a short lunch break, and the next session will continue at 1 p.m. I request you all to join back with the same link. Thank you. Welcome back, everyone. We'll start the session in 2 minutes. Now I request Deepa to introduce our next speaker of the session.
A wonderful afternoon to one and all who have gathered for this technological event. It gives the Beats Association immense pleasure to welcome our alumni, Dr. Ganesh Kumar Mani, a BSc Physics, MSc Nanoscience and Nanotechnology graduate, and a PhD scholar from Nanosensors Lab at the Center for Nanotechnology and Advanced Biomaterials at Shastra University. Publishing over 40 research papers and owning 2 patents titled Low Concentration Ammonia Vapor Sensor and Acetaldehyde Sensor using zinc oxide nanoplatelets, his contributions are very much appreciated and notable. His fields of research lay around nanostructures and their implication in biomedical sciences, doping impacts, and physical science engineering. His work exposure started by his visit to Örebro University, Sweden, and also his active participation in poster presentation competitions, which awarded him the Best Poster Award in Nano India 2015, conferred by Professor CNR Rao, FRS, National Research Professor, Linus Pauling Research Professor, and Honorary President. His doctoral research thesis work landed him Best PhD Dissertation Award. He worked at the Central Glass and Ceramic Research Institute, Kolkata, under Dr. Sunirmal Jana for the Salt Gel Division, and is currently working as a postdoctoral researcher at Tokai University, Japan. Sir, on behalf of the entire Bioengineering and Medical Nanotechnology Department, I would like to cordially invite you once again to the annual conference of Beats Association with the title Bioelectronic Systems and Smart Technology 2021. We are anticipating your views in this field, sir. Welcome, sir.
Thank you, Deepa. Thank you for your introduction. Yeah, it was so nice to see. Okay, just a moment. Yeah, okay. Is my screen visible now? Am I audible?
Yes, sir.
Okay, thank you. Yeah, it was very pleasure to meet all of you. Sorry, just a moment. There are some students working here. I must wear my mask. Okay. Myself, Ganesh Kumar Mani. I'm from Micron Technology Center as a postdoctoral fellow in Tokai University, Japan. I'm proud to be an alumni of Shastra University too. So I'm really happy to give my lecture in this 8th annual National Seminar Department of Bioengineering, Shastra University. So today's topic is sensors for healthcare, minimally invasive and non-invasive techniques. So before going to the lecture, let me introduce my university first. So this name is Tokai University. Tokai means seashore. It was established in 1942. The total number of strength is 30,000 students and it has 7 campuses throughout Japan. And the employment rate is 98%. And our university was founded by Shigeyoshi Matsume. Our university is famous for 2 things. One is the solar car. Our team Tokai has won many world titles like a World Solar Challenge in Australia and in South Africa. And another one is we have won a lot of Olympic medals, especially totally 37 Olympic medals till today by our university students alone. So we have several kind of research center like a Innovative Science and Technology Center, Space Information and Research and Information Center, and especially for the seashore analysis. And this is one of the micro nanotechnology center where I'm working now. So this is our working environment here, and this is our main instrument for this micro nanotechnology center. It is a roll-to-roll processing to prepare a large amount of nanosheets, because our micro nanotechnology center, the main research is polymer nanosheets and its application to various fields. So I am working on the polymer nanosheets for the biomedical applications. So here you can see there is a nanosheet. He is Professor Okamura. He is the one of the inventor of this kind of nanosheet. The thickness of the nanosheet is around 20 nanometer. So we can tune from 20 nano. The minimum thickness we can make is around 20 nanometer. He is totally utilizing this one for various biomedical applications. That's what today I'm going to speak about. And we have another research center like a Nikon Research Center, and Tokai University and Nikon have collaborated and set up a Nikon Research Center in our university. Only very few, less than 10 number only in the world. So we have one of the center here. And what the idea is, the Nikon instrument can supply all kind of microscopes to our university. And what our job is, we have to improve the quality of the imaging technique, or we have to do some add-ons with that one. So this is what Tokai University Imaging Center for Advanced Research. We have all kind of microscopes we have here, and we are still trying to improve the quality of imaging as well as new kinds of techniques too. So let me enter to the today's topic. So in today's topic, I'm going to speak about point of care devices, biomimicking, microneedle, and different kinds of sensor like a microneedle sensor, microfluidic sensor, mouthpiece sensor, and electronic skin sensor, and its future prospects. So first, let me start from the basic on what is the healthcare system. Our healthcare system is very complicated one. It is not depending on only one thing. It depends on primary care, laboratory, hospital, pharmacy, specialist, and it is a bit complicated. So all the systems should work together to find the disease and the diagnosis. That's why now, because in older days, it takes a lot of time for analysis and to meet the doctor and fix an appointment and for diagnosis. So during this stage, the disease get worsened. That's why many people started creating some new way of point of care devices. So this is the old system. Here you can see, once of the patient arrival, they collect sample and processing and test and compile the result and analyze the result. And then the patient can be admitted or discharged from the hospital. So this is a very long processing time. That's why the point of care devices came. So everyone, maybe now there are so many point of care devices available in the market. Say for example, SpO2 meter and glucometer, and then ECG and everything. Most of the, maybe around 60 to 70% of medical devices now, it is compact and low cost, and even everyone can keep in the home also. So it is time saved by the POCT alone. Not only the time saved, even the time for taking some particular diagnosis also saved, so that the patient can be saved. See here, this is a medical equipment in 1800. In the last 200 years, and everything becomes so compact and so cheap and so accurate too. Even the ECG meter also, even it can, now the recent Apple Watch Series 6, it can even alert the stroke also, stroke and heart attack also it can alert. So that much sophisticated point of care devices came, but still we have to improve a lot the sensitivity, and we have to connect with IoT devices. Still a lot of things to do for the better point of care devices. So once we develop the point of care devices, how the India can be benefited. I will tell you one thing. India ranked number 2 in the medical tourism, and India's health capital is Chennai. So minimum 150 to 200 patients are coming from abroad every day, because some treatments, they are not illegal in their country, and the treatment cost is very high, and there is a long waiting time. But in India, we can have the latest technology and we have the best surgeons in the world, and the cost is very low and less waiting time. Say for comparison here, for a heart bypass surgery in the US, it costs $130,000 US, but the same in India, it is in $10,000. That's why many people are coming here and take the treatment and go back their own country. So before developing any point of care devices, first thing what we have to do is we have to find out the target analytes, or say for biomarkers. The biomarkers is simple. In the case of diabetic direction, the glucose is a biomarker. Same kind, there are some different kinds of biomarkers are there, like a predisposition biomarker, screening biomarker, staging, prediction, prognostic, and reoccurrence monitor. So for each and every stage, we have to identify the biomarker for particular diseases. So we can use it as a cell count or small molecules, proteins and fluids. Everything we can use it as a biomarker to find out the disease. So for making the point of devices, three things are very important. One is the instrument should be mechanically stable, and the sensor should be high sensitive, and it is also the biocompatibility. So mainly for the mechanical stability or mechanical reliability, most of the point of care devices use silicon SiO2 or Si3N4. For the sensing material, they use the gold, platinum, antimony, Ag, and zinc oxide, and some other metal oxides too. For in the case of polymers, they use the polydimethyl siloxane, PMMA, and PLLA because it is having the high biocompatibility, cost-wise very low, and it is kind of use and throw devices, single-use devices, and easily can be surface can be modified. So before this is the first topic I'm going to speak. This is biomimicking. So biomimicking is simple. The design inspired from the nature. So every people know very well this is the lotus leaf effect. The surface is hydrophobic. So using this one, the inspired and hydrophobic T-shirt and hydrophobic screen, smartphone, and the shoe spray, and even the windshield also. Not only the lotus leaf, there are some many things inspired from the nature and produced. So based on the kingfisher bird, the Japanese invented the bullet train, which can go very high speed, and even the bird feathers. Using bird feathers also mimicked as a flight wings, and then shark skin, because shark skin use the swimmer's cap, because shark skin has a very low drag. So the swimmer, when they wear the cap, and he can swim very faster. That's why. And again, this is a box fish. It's this dimension also. It is gives very low drag. That's why it is a high fuel efficiency too. So the painless microneedle, what it is inspired is, so why we need the microneedle first? So nearly 20% of our global population affected by the needle phobia. It costs 1.3 million deaths annually, because many people don't want to go to hospital because of this needle phobia. Because if you want to extract something from your body for the analysis, the only way is injection. The common injection size is around 900 micrometer, which is painful. So if you want to create some some needle with very less pain, we have to go for the micro needles. So micro needle idea is inspired from the mosquito bite. Here is the skin, and this is a mosquito. It is biting. Only female mosquitoes can bite. The female mosquito extract blood at the amount of 1.9 microliter for 2 minutes. And you can see the video here, how it is biting and extracting the blood. And you can see this is a blood vessel, and the mosquito is biting here. This is a mosquito's labium, and it makes the puncture in your skin and inserted the labium. It is a very fragile one. It is inserted, and the labium goes inside and to find out where is the blood vessel, and then sucks the blood. So here it is not puncturing directly. It is giving some vibration, and then it can puncture. Because as I said before, the mosquito's labium is soft, so it cannot puncture directly your skin. Your skin is little bit harder. That's why it needs to give some vibration to make it harder. As you know, because when you go to the hospital, before injection, they used to rub your skin with some ethanol or something. So that one is not only clean your skin, also it can increase the rigidity of your skin, so that the skin gets harder. The injection can go easily inside your skin. That is also one of the important thing. So based on this inspiration, we wanted to develop this mosquito's labium in artificially using some metals. So you can see here, this is a microscopic image of the mosquito's labium, and the size and the length is around 3.5 to 4 millimeter, and the length is inner diameter is 30 micrometer. And here you can see this is a commercial needle, which is 900 micrometer. You can see the size comparison, 30 micrometer and 900 micrometer. So we want to artificially create this 30 micrometer mosquito's labium using some metals. So why I say as a painless microneedle? So what is the main thing causes the pain? You can see this is a cross section of the skin, and this is the commercial needle, and here is the micro needle. So when the commercial needle goes few millimeter into your skin, and then it affects the pain nerves. So here in this micro needle, it can go very few micrometer, so it will not go and disturb the pain nerves, so that you cannot feel any pain. So if you want to extract something or insert something, you can use the micro needle also. It can go and dissolve, and it can deliver the drugs also easily in the skin layer. There are some different kinds of microneedle available, like a solid microneedle, coated microneedle, dissolving microneedle, and hollow microneedle. But today I'm going to speak about the solid microneedle and hollow microneedle alone. So this one you can see. So this is the, as I said, this is a mosquito's inner diameter 25 to 30 micrometer. So here you can see, this is a titanium microneedle created in our laboratory using sputtering technique. You can see the same diameter, 25 micrometer, and the outer diameter is 50 micrometer. So you can see the comparison here. This is a 900 micrometer commercial microneedle, and here is the titanium microneedle. The titanium microneedle can be produced in few millimeters also. And instead of using the commercial needle, we can use the titanium microneedle. So here, the main important thing is, if you want to deliver some drug, you need a large needle with a high portion. But here, we are going to use this one as a sensor. So we want to modify something onto the surface of the titanium microneedle, and we want to use it as a sensor. For sensing, we need a very little amount of body fluid is enough. That's why we don't need to go for a something higher diameter. This is the production technique of the microneedle. Say, you can see here is a copper wire. It is around 25 micrometer diameter, which same as the mosquito's labium, and surrounded coating with the titanium. So this is it will continuously rotating, and the needle is here. So after continuous rotation, this is inside the sputtering chamber, and this is a jig, and here the titanium microneedle will be fixed. So once after finish the sputtering, we just put the titanium microneedle into the HF solution, and the inner core copper wire can be melted out, and only the hollow titanium microneedle we can get. So you can see here, this is the coated after sputtering, and you can say the hollow structure. So this is a hollow is created by the HF solution. So after creating the microneedle, we have to do two steps. One is pain evaluation, and another one is the flow rate evaluation, so that you can analyze easily. The first, for flow rate evaluation, we purchased some other needle from the company also, like a Nanopath 33 and stainless needle, and this is the titanium microneedle created in the laboratory. First, for the extracting solution, we use the blood as well as the water, and we checked how much microliter of blood and water can be extracted using this titanium microneedle. For extraction, we use the piezoelectric actuator, and it can create positive and negative pressure, so that the blood and water can be sucked out, and we can estimate. So the 1, 2, 3, this is for the blood. So usually blood is very denser compared to water. That's why the flow extraction rate is bit lower. Say, for example, for the titanium microneedle, only 6 microliter per minute can be extracted. But in the case of water, it is more than nearly 45 microliter per minute can be extracted. So from this one, we can confirm the microneedle can be able to extract something from your body. So the next test, I said, there is no direct technique for the pain evaluation. So that's why we use the indirect method of alpha amylase activity. Because when you feel stressed, the alpha amylase enzyme activity in your saliva will be much higher. So based on this one, you can find whether it is feeling much painful or not. So that we fix the needle here, and then we injected in the mice leg, and immediately we collected its saliva. So after collecting, we just analyzed the alpha amylase activity in our Tokai University Hospital. So here, not only the single microneedle, we tested with the different kinds of diameter, like 35 micrometer, 70, 95, 100, 150, and 200. So we want to identify at what level the pain is very less until you can see here. So this is until 100, exactly 105 micrometer. So until 105 micrometer diameter, the alpha amylase activity is very less. So it means until the 105 micrometer, the alpha amylase, the stress level is very low. But once it is exceeded the 105 micrometer, the alpha amylase activity is very high. So it indicates that it is getting very painful or stressed. So that's why we limit our research into less than 100 micrometer microneedle creation. See, after this one, you can see this is a titanium microneedle and fixed with the micro glass tube. So we want to check whether there is some crack or something is there on the needle or not. That's why we inserted this glass tube and passed the water, and there is no visible crack here, and there is no leak in the water. So that's why we confirmed that the hollow structure is good and perfect. So with the help of some company, what we have done is we have created the wristwatch type sensor. In this wristwatch, so here there is a 4 needle we fixed, 4 titanium microneedle, like a hollow needle we fixed here. And then in top of this one, we fixed the glucose sensor, and then as well as the insulin patch. So what it will do is, it will puncture in your skin and extract the blood, and then analyze in this system, and then how much insulin you need for your body, it can supply immediately through the another 2 needle. The 2 needle can be extract the blood, and another 2 needle can inject the insulin to your body. So going to the next one, instead of using the hollow microneedle, we thought that why don't we use the solid microneedle for the sensor? So we thought that we know very well our human cell range from 5 to 100 micrometer. But if you want to take some single cell, or you want to measure the pH inside the single cell, you need some micro electrodes. That's what we thought of developing single cell pH sensor. So using this single cell pH sensor, we can identify the cancer cells easily. So usually the cells maintain an intracellular pH within a range of 7.1 to 7.2. But the cancer extracellular environment is known to be 6.2 to 6.9. By identifying this difference very in the high efficient way, you can identify the normal cell and cancer cells separately. The research can be useful for the drug companies, because in the drug company, what they will do is, if they want to develop some drug, they culture the cell. There is a millions and millions of the cell, and then they can put some drug and they can see the effectiveness. So they can take, in that case only, they can take the average data, not how the single cell is react to that particular drug. So in this case, if you develop some single cell pH or single cell temperature sensor, you can identify, you can supply the drug to that single cell, and then you can identify how the single cell is reacting to that particular drug. That is our motive. Not only the pH, we can use the temperature also, because pathological cells are warmer than normal cells. We did not do many research in this temperature sensor. Our main focus is only on the single cell pH sensors alone. There are some other people who already developed some single cell pH sensor using nanopipette sensing technology, and then single cell photoacoustic thermometry and intracellular single cell pH measurement using optical method. But the technical difficulties on the other methods are they are using some quantum dots or pH sensitive dyes for the modification. So we don't want to use any modification or labeling. So without labeling, we want to detect the pH directly. That's why we came up with an idea of using micro electrodes. This is a tungsten rod which is having the 300 micrometer and coated with AgCl ink and then zinc oxide by sputtering. This is we call it as a 2 micro electrodes. And then we inserted into the mice brain and mice bladder and test the pH. So before going to this one, we always do the testing with the fish egg, because it's easily available. And so we can take the fish egg and then add the citric acid, small amount and another small amount, and we checked the pH value 6, 5.2, 4.6. This is measured by the commercial pH meter, and then we test with our pH micro needle also. This is a 2 micro electrodes also, and then this giving the good linearity. The sensor is working well. And then here you can see this is a mice brain, and then we inserted 2 electrode. The one is the reference electrode and another one is the working electrode. So this is a testing with a pH buffer solution like pH 2, 4, 6 and 9, and it is having the good stable value. And then here you can see AgCl microneedle electrode and AgCl glass electrode. Also it is having the good linearity. And here you can see theoretical value and then estimated value by the microneedle. So what I mean the theoretical value is it is measured by the commercial pH meter. And here is the estimated value by the microneedle. There is a difference between theoretical value and the value by the microneedle. It is because the sensor surface is affected by the tissues and blood. So we are trying to make it as a smooth surface or using some anti-fouling material on the micro electrode. So get rid of this problem. So instead of using 2 electrodes, see here I said I am using 2 micro electrodes. But instead of using 2 micro electrodes, we thought of using a single electrode. So this is a tungsten wire, and using the electrochemical etching, we use as a 4.8 micrometer tip diameter and coated with SiO2 layer. SiO2 is an insulating layer. So the tungsten is a metal, so we don't want to interfere in that any potential difference. So first we coated with the SB2O3. This is a working electrode, and we put a mask here, and then AgO3 was coated. AgO3 was the reference electrode, and finally we removed the mask, and the final electrode looks like this. So here we take the contact, and initially, as I said, 300 micrometer is the titanium microneedle, and after all the coating, it became 343 micrometer. So this is a close look of the tip of the microneedle, and this is the separated layer, and here is the reference electrode, and here is the working electrode, and both layers are separated by the SiO2 layer, and here is the cross-sectional view you can see. And it was, we take the XRD to confirm the material at the particular area. So here it was confirmed as the Sb2O3, and here it is a AgAgO3. And you can see the separate layers, that the core is the tungsten, and the first layer of Sb2O3, and the second layer, insulating layer, and the final layer is AgAgO3. So here you can see the EDS also, it is very clear. It is Sb2O3, it was well separated, and AgAgO3, and both layers were separated by the SiO2 insulating layer, so that it is the layer is separated, so there is no interference between these two layers. And then, as I said, the single cell microneedle, we tested with the HepG2 human liver cancer cell, and here is the single cell separated from the many cells, and this is a microneedle, single microneedle, and here you can see the microneedle is punctured the cell without damaging, because before puncturing we tried to puncture with the different kinds, not the different cells of your HepG2, and once we started puncturing, the intracellular liquid came out, but in this case it did not came, but it was perfectly punctured. But at the same time, the problem is other cells are approaching and then making a contact here, so this will make the error in the data. That's why we are thinking to use some antifouling material on top of the microneedle. So as a next step, as I said, it is for a single cell, so we cannot use by our hand easily for each and every measurement. That's why we collaborated with Miyahara Corporation in Japan, and we developed this instrument. So what it can do is, as I said before, it can automatically, it can puncture. We can actually program it. So 30 seconds, it can go and puncture the cell, and 30 seconds, it can do the measurement and then come back. Not only that one, the important thing is it can give the vibration. I think maybe it is not clear here. So it is in the tip of the holder is having can give the frequency of 4,500. So when we puncture, it can give the vibration. As I said before, the mosquito's labium cannot go directly into your skin, because the mosquito's labium is a very fragile and very soft. So before puncturing, it can give some vibration. We wanted to same replicate here. That's why on the tip of the microneedle, so it can give some vibration while puncturing, so that the cell surface can become little harder and easy to puncture. So, and then we tested with the potential before puncturing, it was 85 millivolt, and potential after puncturing was 135 millivolt. So this is the experiment with the fish egg, and here is the microneedle. So, and then the another problem comes, we cannot easily direct to puncture. So this is a kind of fish egg. We try to puncture, but it is keep on moving. We need something to hold that one so that it can easily puncture. Then we can come up with the idea of a nanosheet wrapping method. So we take the silicon wafer coated with PVA, that is a sacrificing layer, which is easily dissolved in water, and then coated with the PLLA, both done by spin coating method. After spin coating, we just put into the water. So what it will happen is, so you can see here, video is. Oh, okay. So here you can see the nanosheet is floating. As I said, the PVA is a water dissolving polymer. So once you put it here, the PVA layer will be dissolved, and only the PLLA can be floated here. Then we can transfer onto the fish egg or cells also. In this case, we use the nanosheet to coat on the fish egg. So here is the petri dish, and we put the fish egg and coated with the nanosheet. And we tried with the two different thickness. You can see that in the picture, the nanosheet is covered with the fish egg. It is 200 nanometer nanosheet and 60 nanometer. In the case of 200 nanometer, what happened is there is some air bubble formed here inside. And then in the case of 60 nanometer, it completely covered the fish egg and it cannot move, so that we can easily puncture. And then you can see inside this one, there is some vibration. This is a fish egg. And then using the vibration frequency 4,500 hertz, we just applied, and then inside the fish egg, it is a vibrating. So vibration also confirmed at the tip of the microneedle. So not only this one, we can use some microneedle patch also. Not only the single microneedle is mostly helpful for analyzing. like analyze sensing purpose or actuator purpose. But if you want to deliver some drug to your skin, it needs a large amount of microneedle. That's why many people started using this kind of microneedle array, so that they coated with the drug and then it can puncture. So it will be dissolved in your skin and then the drug can be delivered at the particular body. So moving to the next topic, electronic skin, as I said before, the nanosheet. That's why that is a simple nanosheet. If you want to modify something in the nanosheet, it can be called as a electronic skin. So why the electronic skin can be used? So it can be used as a temporary as a tattoo. Say here, these are some example published by other people. So it can monitor electrical muscle activity and body temperature. Even the skin vapor also can be modified. So what we have done is here, we tried to measure the pH. As I said before, in the same microneedle, pH materials can be deposited on this nanosheet. So this is the same. Here the nanosheet is different. Instead of using PLLA, we use the PDMS because it is having the high flexibility. That's why this is a titanium is a buffer layer, and gold was coated by sputtering as a electrodes, and then coated with AG, AgA03 and SbSb2O3 is coated here. And then the freestanding you can see here. And then we just you can see in this video, the nanosheet is put it on the artificial hand. So after bending and twisting, the nanosheet is not break. So still it is having its flexibility. And the next step, we tried to measure the sensitivity. And then here you can see the pH with a different pH 4, 5, 6, 7, 8. And then it gives the good linearity. Here is the electrical contacts. And we have done test also with the different kinds of test. And then here is the stability we have tried. And then because usually, as I said, the electronic skin, it is attached to your skin. But when you are going the outside, interact with the environment, the temperature difference between the indoor and outdoor can be changed. So in that case, the nanosheet, the electronic skin should not affected by the temperature. That's why we applied the nanosheet onto the hand, and using the simple hair dryer, and we artificially increase the temperature 32, 34.9, 38.2. In that case, we measured the temperature, we measured the pH. So in that case also, there is not much difference. So that nanosheet is not affected by the temperature also. So it can be used for measuring the sweat pH easily. So this is the ACS sensors. It was published as a cover image too. And this is a pamphlet created by our university. Your health in your hands, novel wearable technology can easily detect heat stroke. Because in Japan during summer time, many people are affected by the heat stroke. That's why the Ministry of Environment asked us to create such kind of sensor, and then we did. Now it was working well. So still we are moving to the next step to increase the sensitivity of the sensor. So not only that one, so here it is the same material can be mounted on the mouthpiece device because many people lack of hydration can lead to muscle cramping, dizziness, and nausea. Because in our university, as I said, we have a lot of Olympic medalists here. So many athletes are practicing every day. So they are to make them keeping athletes hydrated. The sports department asked us to create such kind of sensor to measure the dehydration. So here, this is our lab student. He is wearing this mouthpiece device, and we asked him to drink mineral water, black coffee, Coke, which is having the different pH 7.6, 5.6, and 2.4. Here, this is only one sensor, but actually we put 3 sensors here. One is at the near front teeth, and near canis, and near back teeth. So why this one is, we want to identify which place of your mouth is more sensitive for the pH. That's why we put 3 sensor and measured it here. And finally, we found the near the back teeth was much better results. It is having the high sensitivity. That's why we are developing new sensor to be placed at the near the back teeth, so that it will be much better and can give good sensitivity. So moving to the next topic, microfluidic devices. Many people know what is the importance of microfluidic devices is. Even with very low volume, we can measure, we can analyze and decrease reagent consumption and shorten the analysis time and reduce the overall cost of the analysis. So even a lab on a chip can be created. It can do the multiple functions. So metastases are the cause of 90% of the human cancer death. You might have studied. So there is a primary tumor, and the primary tumor cells can be mixed up with your blood, and it can go on and form as a secondary tumor. So it can produce another cancer area. because the cancer cells can be transferred from one place to another and make it the cancer more severe. That's why we want to detect the circulating tumor cells. These bloodstream cells are usually called as the circulating tumor cells. And for the early detection of cancer, it will be helpful. And the choice of cancer therapy can be chosen easily. And number of CTCs in blood is in relation with prognosis of cancer, and monitor cancer patient is cancer treatment response, how the cancer drugs can be effectively used here. In that idea, we created the microfluidic sensor with this AgCl and zinc oxide. So this is a gold pad, and here is the AgCl. And the other side, we masked and coated, deposited using sputtering zinc oxide. We do the commercial lithographic process, photolithography process only to create this microfluidic channel. The microfluidic channel width is 140 micrometer. And this is our direction methodology. So we take the pH buffer solution and we pass through here, and there is outlet where there is a sensing materials here, AgCl and zinc oxide. So this is a dry condition, only air is there, and then we started passing. So in this case, after 27 seconds, it got stable. So this is for the pH 2 and pH 4 and pH 7 and pH 9. So after nearly 30 seconds, the values get stable. So the response time for this kind of sensor is nearly 30 seconds. Next step, instead of using the pH buffer solution, we passed through the biological cells. So the biological cells are human lung cancer cell, rat muscle cell, and dog kidney cell, and the flow rate is 120 microliter per minute. So in this one, we take the cells. So initially, instead of cells, we use only the medium, DMEM. So there's a black color. This is a DMEM alone we passed, and we take the potential difference. And then along with the DMEM, we passed the A7R5, A549, and the MDCK and checked the difference. But unfortunately, A7R5 did not give, it is same as the pH value as the DMEM, that is a medium. And in the case of A549 and MDCK, it gives some difference potential. So it means that these two cells have the different pH values, and then it can be easily detected by this sensor. This is the initial step only for detecting circulating tumor cell. Still, the lot of process have to do before passing the cells here. So initially, you have to use the DLD array to separate the cell based on size. After that, once you pass through this kind of device, it can able to identify based on this potential difference. So not only the photolithographic method, there are some other different methods also available to create microfluidic devices, like a xerography based microfluidic device. It's very easy. You can use the cutting plotter to design and then coated with like a lamination sheet, and then you can heat up, so you can easily create the microfluidic device. Not only that one, you can use the paper-based disposable microfluidic also. You can use by using the filter paper and the wax crayon and heat it up. The wax can be melted and the channel can be created. So with this one, the summary is the first step using the main material creation is a single microneedle, and with a multimeter, we can easily identify the pH. The pharmaceutical industry for early drug discovery can be very helpful, and it can be easily integrated with the POC devices and can modify it for multiple analytes. So in this total research is mainly focusing on the pH alone. Still, you can use it for glucose or temperature, many things you can do by changing the material alone. Our next step is to detect the neuron membrane potential using the same microneedle electrode. We want to put it in the axons, and then we want to check the ion imbalance, so that we can easily identify the Alzheimer's and Parkinson's disease in the early stage itself. And this is the current challenges we have faced, and we got the advice from the doctor. The adult skin and the child skin have the different thickness, thickness of stanium corneum. So that's why they asked us to develop such a identify or differentiate how this microneedle can be worked for the adult people as well as the child people. And then this is the activities between Tokai and Shastra, because as you know, we started the MOU between Tokai and Shastra in 2007. And then the first visit was done by Professor John Bosco Balaguru. And then we got the SAP student in 2009, Akshay and Dinesh. And currently they started working here joined as a master student here. They are working here. And then last year, Priyant and Hari came as a SAP. And this is Dr. Prabhakaran Shankar, who was as a postdoctoral fellow in Tokai University. Now he moved to SKKU Korea. And this is Dr. Veena. She came here and we jointly worked and published, and Professor Tuchia is her co-supervisor also. And this is Professor Rajan. He visited also Tokai University and gave some lectures. And not only that, the professors from the Tokai University also visited Sastra University, and we conducted the Indo-Japan workshop in 2018. And some other Japanese students also visited Sastra, and then they enjoyed and they stayed for 2 weeks. And we had a lot of research activities between Tokai and Sastra, and still we are continuing. And our MOU is already extended for the next 3 years. Maybe students can come here and work together. Yeah, thank you so much.
Thank you for a highly diverse and informative session, sir. We will now have a short question and answer session, sir, posted by the participants. So,
yes, please.
Type of sputtering was done, sir?
Sorry?
Sir, which type of sputtering was done, sir?
Because we use some 2 different kind of sputtering, like RF sputtering and ECR sputtering. For insulating material, we use the RF sputtering, say for zinc oxide and some other antimony, we use this RF sputtering. And we have the ionic sputtering, that is a ECR sputtering. That is we use for the gold and platinum and titanium. We have just 2 kind of sputtering here.
Okay, sir. Sir, and the insulin delivering sensor, how much accurate is it, sir?
Still, we don't think about the accurate. Still, it is just a prototype model only. Still, it is not completed yet.
Okay, sir. Sir, and a few more questions, sir. Yeah. Were there any false positive occurrences in readings of pH in microneedle? If so, what could be the positive reason for that, sir?
That's what we are still confident that we tested with nearly 25 to 30 mice till today. And then almost in everything, it is giving the good results. But there is more chances of failure. As I said, we are stacking multiple layers of thin film on each sensor. Whether if it gets too much higher stress while operating, then there is more chances of failure that needle. So always we have to check with the reference data and then we have to finalize. We cannot blindly believe the data given by the microneedle.
Okay, sir. So the last question, sir. Could the same needles be used for observing ionic phenomena across cells for a longer period using patch clamps, sir?
Yes, we can do that. We are still doing that one. That's what we are trying to use it for the long-term study of that microneedle.
Okay, sir. So thank you, sir. Your views and ideas are mind-blowing, sir, and I take pleasure in expressing our gratitude to you, sir, for answering the questions raised by our peers, sharing your ideologies amidst your busy schedule. We are looking forward for another wonderful interactive session with you, sir. Thank you, sir.
Thank you. Thank you very much.
Thank you, sir, and thank you, Deepa.
Fashion is fickle, and this comes at a cost. In fact, the fashion industry is responsible for emitting almost 10% of global carbon emissions. And the reliance on synthetic fiber production often involves the use of toxic dyes and chemical treatments which use and pollute vast quantities of water. But long before any supermodels, colourful organisms have strutted down nature's catwalk. So that's why the company Wearwool are now taking inspiration from these natural trendsetters to produce coloured textiles from naturally occurring proteins. Proteins are the building blocks of life. They're found in everything from skin, hair, and muscle. And the structure and arrangement of these protein molecules determine their properties. Up first on the catwalk was the beautifully vivid pink of the Discosoma coral. produced by a colourful protein that evolved to protect and feed a symbiotic algae that lives in its tissue. The DNA sequence that codes for this pink protein can be copied and inserted into bacteria. These bacteria can then be used to produce the protein safely in a lab. This protein is then extracted and made into fibres, offering a low-cost, sustainable method for producing coloured textiles. And because there's no limit to nature's library of proteins, fibres can be designed with properties from the ground up. By harnessing the power of proteins, Wearwool is hoping to revolutionise the production of our clothes, with fibres designed to be 100% biodegradable, making clean fashion the naturally fashionable choice. This little critter is the mantis shrimp, perhaps better known as the smasher shrimp, due to its powerful front clubs, which are used to obliterate its prey. So, how is it that this shrimp is helping us to design stronger and more lightweight materials? A decade ago, scientists began to unravel the mystery of the shrimp's success. They discovered that the material that makes up the clubs was arranged internally in a spiral-like structure known as a helicoid. This is a fantastic shock-absorbing structure formed from sheets of parallel fibers which are stacked and rotated, allowing it to dissipate energy efficiently. And now, by reverse engineering this natural architecture, the company Helicoid Industries have been able to incorporate it into modern designs of composite materials. The benefit of using helicoids is that they have a very small surface area and are formed from far less material than a solid. By using them in composites, Helicoid Industries can massively reduce the amount of raw materials used in production, making them lighter with a smaller environmental footprint, all without sacrificing strength. Their plan is to incorporate these natural structures into materials to build things like wind turbines, cars, sporting goods, and eventually into aeroplanes. These enhanced designs would allow for more fuel-efficient vehicles, as well as allowing for longer and stronger turbine blades, increasing their overall energy output. Not bad for a little shrimp.
Ready to know what inspires slips? It is a carnivorous pitcher plant that has a unique repulsion property. The nectar trapped within their overlapping epidermal cells makes them slippery. This makes the insects get attracted and slip right into the bowl of digested juices. This phenomenon inspired the structure of the porous solid surface and the lubricant layer on slips. This too has pitfalls that include the very long fabrication process, a limited fabrication size, and an unstable lubricant layer. Lotus leaves too display a similar characteristic. Could you think of what makes them different from the pitcher plant? Stay tuned.
Hello everyone. Now I request Kamalam to introduce our next speaker of the session.
Good afternoon all. Asimo Robotics Private Limited, a service provider in automation and robotics, which was established in the year 2012 in Kochi, Kerala. It is a company that provides engineering products or solutions and consultancies in advanced robotics and artificial intelligence. Their services extend to various fields such as medical, defense, space, and sports. Asimo Robotics has been featured in Forbes magazine 2018 as one of the most promising AI and robotics companies in India. We have with us Mr. T. Jayakrishnan, founder and CEO of Asimo Robotics Private Limited. He has more than 26 years of experience in the field of embedded system design and software development. He has prior project experience with many renowned government and private agencies in Europe, US, Japan in the field of defense, space, and nuclear power generation. Apart from heading the operations at Asimo Robotics, he is responsible for the conceptualization, research, and development of the interactive social service robots ISRA 2012, Sayaba 2016, Chaya 2020 to address various requirements in banking, retail, healthcare, space technology, security, and hospitality sectors. He has published 2 research papers and has been part of reputed companies like Energy Technologies, G4 Matrix Technologies, Rental Technologies. Sir, on behalf of the India Beats Association, it is my pleasure to welcome you to BEST 2021. We are all inquisitive to know your journey in the domain of robotics. This felicitates us to have you as our guest speaker. Over to you, sir.
Sir, can you please unmute yourself? I think you're muted.
Hello?
Yes, sir, now you're audible.
Yeah, good afternoon, everyone. Thank you very much for the nice introduction. Let me share the slides before I start. Is it visible to you there? Hello?
Yes, sir, it's visible.
Am I audible?
Yes, sir, you're audible.
Good afternoon once again. I hope you can see the first slide there. If there are any glitches, please let me know so that I can put it back to the normal mode. Sometimes it happens when it is in presentation mode. It is not scrolling properly. I have experienced it before. Please let me know in case. So as we all know, the pandemic has devastated our economy, the world economy, and it has penetrated through almost all areas of our life and the social life particularly. So far, you can see it's around 133 million people affected and 2.9 million people. I mean, they have, more than that has passed away because of this. And then, as you can see from the slide, the impact on the economy is around $4 trillion US. So it is actually, we can divide the world into two, like before pandemic and post pandemic. So as you know that every time whenever there was a difficulty, it was technology who has helped us in the right time with its abilities to come out of the difficulties. Here also the same thing happens. As far as robotics is concerned, specifically service robotics is concerned, post-pandemic era is a good time for service robot because the acceptance is actually completely upside down now. 2 years to 3 years back, even 3 years back, I would say, because I have been working with robotics for the last 15 years. The perception of general public about robotics was it's something which actually coming to take away the job opportunities. But that has been completely upside down, and people have started accepting robotics and robotics enabled support services in a big way post-pandemic. So in this presentation, we will try to understand what are things that robotics, particularly service robotics, can help out to fight the pandemic. Are you able to see the screen moving?
Yes, sir.
So let us see what are the important aspects which necessitates the use of service robots. As you know, the proportion in which the population is increasing in comparison with the resources and services, there is a huge deficit. So particularly in urban areas, in metros, if you look at, you can see that the development is skyrocketing. And if you take the infrastructure facilities also, you can see that most of the developments are happening in the C direction, like skyscrapers. Means people are actually densely populated. So their requirements in terms of services, food, and other facilities also in the same ratio. So there we need to have technologies. It's not only robotics. If you take the case of agriculture, if you take the case of infrastructure or real estate development, it is the same thing. Like it is not possible for somebody to put a brick on the top of other and construct all these things. So you need to use big machines like earth movers and other equipments to construct in that scale. So if you take the case of food and agriculture, biotechnology is there. So just like that, in various areas, robotics inherently has the capability of getting connected or providing services in almost all areas of human life. So, and recently the developments in AI also supported it very much to be able to come out of factories and be a part of our life. Second reason is like the demographics. I would say if you look at, I can see examples as security services. If you look at, you can see that most of the people who are employed are more than 50s, 60s retired people. You won't get youth to do this job. And if you look at another example like coconut harvesting in Kerala, you won't get any resources who can do that. So like this, there are a lot of areas, blue collar jobs. After some time, you won't be able to get people to assist you in supermarkets. So likewise, in almost all areas, you can see there is a huge offset for resources in terms of blue collar jobs. And even though, even if they are interested in doing this, the quality of service and the morning to evening, are they able to provide the required quality of service? No. So that is also another reason. And then world is changing every day. World is changing, like their requirements are changing every day. So are we able to adapt to these changes? Are we able to reskill ourselves to adapt to these changes? No. So for these reasons, service robotics is actually gradually catching up. But post-pandemic, what happened is, like, most of the cases, you can see that the involvement of service robotics has become very important. If you look at the service robotics industry, you can see that it's a huge market. This is actually pre-pandemic. This statistics is pre-pandemic. Around $100 billion USD market is going to come up by 2025 in terms of service robotics applications. But I think this could be many folds post-pandemic. So if you look at the growth, you can see that the service robotics itself has grown by 32% post-pandemic, and logistics, particularly in that sector, we are actually experiencing more than 100% increase in demand, and medical robotics about 30%. See, one of the reasons which I could cite here regarding the spread of the disease, like when disease can be, the epidemic is becoming, it was earlier epidemic and then soon become pandemic, is mainly because of the travel and transportation. So there are a lot of areas where robotics can help out to minimize the human involvement. Let us look at the various aspects of possibility of robotic services to address this pandemic. So as you can see from the slide, one thing is social behavior, personal hygiene, all these things is actually now household terms. So people are always talking about what is it like, social distancing, isolation ward, quarantine zone, reverse quarantine. All these words are very common now. So that is one aspect. And then the environment hygiene is the workplace hygiene, where we need to have frequent cleaning, frequent disinfection. So that is another area where robotics can help out. And another one is logistics. These areas can be divided, but still I want to club it because we will be talking about all these with the examples. So logistics, again, there are logistics requirements as the e-commerce has established and the e-commerce business has boomed up. There are a lot of logistics requirement, but that is a well-defined, what is it, like a factory kind of requirement where human involvement even otherwise is minimum. But if you take the case of workplace logistics, in intra-organizational logistics, in various market sectors, you can see that robot has to work alongside with human beings. So I think that kind of logistics requirements can be addressed. And then nursing. And then nursing is nursing or caregiving for patients who are actually infected with contagious diseases or any other diseases, like, or maybe it is post-treatment care or post-surgical care. Various use cases are there. And finally, surgical systems. See, one of the reasons I was very much interested in taking part in this webinar is mainly because it very much aligns with what we do. Because we have been working as a service robotics company. And when the pandemic came, we could easily customize, pivot into this, addressing these requirements. We could easily customize as we were keeping most of the modules modular, and then we could reuse many technologies that we have been working with to address these problems. So your theme of this webinar was very much in alignment. So that's the reason I got interested. We will see one by one what are things it can address and how is it able to address these requirements. So as I told you, in fact, even now after 1 year, the pandemic actually started affecting our geography. During, I think, Kerala only came for the first time, unfortunately, and then that was January, I think, and then February. By March, actually, we also started having problems as a lot of, people who came from the infected areas. And then till now, if you look at, we had elections last week. So till now, if you look at, you can see that the public is actually not having the proper understanding of this disease, how it is getting spread, what all things you have to do, what you don't have to do. All these things people are not clear. And along with that, there is a lot of fake news which is spreading. So I cannot keep aside the importance of continuously educating people on the what is it like the precautionary measures that they have to take, and about the care and cure once if it is somebody is infected. So these two robots, as you could see from the picture, are the robots we deployed in a workplace. So primarily the point which I would like to tell you is that with the help of robots and AI-enabled systems, we can spread, effectively spread the awareness about the protection, the precaution, the care and cure among public very effectively. This two robots, as you could see, one is actually talking to people and then showing them videos from WHO. Another one is actually answering questions. I can show you videos towards the end of this presentation. I have videos in just one single video. I just combined all this. So I will be showing towards the end of this. So this is one use case. And second use case is, of course, related to the health screening of people in public places. So I think it is very effective if you implement in workplaces because most of the people, they have a certain work culture and they are able to quickly adapt to this. They accept technology very quickly. So what we could do is that one is like health screening, where the robot or the system which performs temperature screening and check whether the people working the resources are wearing masks properly. You know that most of the people are wearing masks not very correctly. Somebody is wearing on chin, somebody is wearing just underneath the nose. So all these things can be monitored continuously and then advise them, warn them to wear it properly. And then social distancing. Social distancing is something which happens by, it's not a deliberate thing as we just continue, continue the same kind of behavior that we have been following before this pandemic was there. And then people started, you can see that if you go to a mall, you can see that one by one it forms a cluster and then people started interacting. And in most of the public places, railway stations, wherever you go, you can see that this is happening. So it is impractical for a human being to identify this and then advise them to keep a safe distance. But we have successfully implemented this, wherein the robot will be scouting and then looking at people standing close by. So if it is more than 2 people, 3 people standing close by, the robot will move towards them and advise them to keep a safe distance. So another aspect is that it is more acceptable. Like if a human being goes there and advises, it won't be well accepted. But this worked really well. And finally, the sanitization, which is something which can be done with the help of very simple devices, but as a comprehensive solution that also is integrated. So the robot actually sprays sanitizer. So we have successfully implemented it for elections. As you can see from the picture, we could handle a queue of 300 people without any break, checking their temperature, mask, and dispensing sanitizer and social distancing in less than 1 minute. So this is actually the environment hygiene, wherein you know that some of the potential areas through which the virus is spread is through the door handles, knobs, where the people frequently touch or use. So you have to sanitize those areas. So we have employed robot to do that. It's actually a roundabout way because our robot was capable. So we did it this way. Otherwise, you can just spray disinfectant on this. And then also with the gadget disinfection using UV light. And then, of course, large area sanitization and disinfection. So that actually we are actually working on a, you can see this 3D rendered model on the right-hand side. So we have not yet released it. A lot of companies are working already. There are many products on these labs. So that is another use case. And finally, as far as the caregiving is concerned, you know that it is impractical for you cannot avoid the risk of getting infected if you are providing care or nursing to the COVID infected patients or any contagious disease, same thing. So what we did is like we have developed a solution. Again, there are a lot of solutions. If you look at after pandemic throughout the world, there are a lot of solutions. Not only this. This robot actually what it does is like it dispenses food and medicine to COVID patients autonomously. But the fact is that this has to be done fully autonomous. Why? Because if a patient, if a person is involved, if the caregiver or the operator is always behind it, then he is not completely out of risk. So what it does is like it carries the food and other consumables inside the COVID ward, stops autonomously at each bed or each room, and then dispenses the food and other items. And also in the return journey, it collects the used items. It can be plates, it can be disposable plates or mask or anything which the patient used. To be inside that, there is a black box which is UV enabled inside that, and in the return journey, it disinfects that. So the operator or the human caregiver can safely handle it. And it also has a sprayer which is a targeted spray in case of any spillage of any bodily fluid through coughing, sneezing, or vomiting. So you can set the robot to that location and it autonomously sprays this disinfectant on the top of that, so that the first level cleaning is done. Now you can send human beings for the second level detailed cleaning. That's much safer. And finally, this robot also has got this telemedicine facility so that the doctor or caregiver can interact with the patient sitting outside. So this was very successful, and it's even now also they are using it by Government Medical College. And this is another very interesting use case which we launched again last week at Narayana Hrudayalaya Hospital, Bangalore. So this use case is very interesting. In the last slide, you have seen that we have introduced the robot to help health workers getting infected. But this time, robots are used to protect the patient. This use case is like, if you could look at certain hospitals like NH, Narayana Hrudayalaya, you can see that a lot of surgery is happening per day. 30-40 surgeries are happening, and a lot of people are admitted to the ICUs, surgical ICUs. So these patients are obviously prone to infections because their immune system is down post-surgery. So same time, there is a lot of requirement of consumables and microbiology specimens transporting back and forth between surgical ICUs, clinical laboratories, pharma, store, operation theater. So what happens is that all these items are currently being carried by human beings. They are called medical runners, so they carry it. So if you look at, you can see there's a lot of human movement inside the ICU, which is not good at all. So even before COVID, we started working on this project even before COVID, but post-COVID, it has become a very pressing issue. So what this robot does is like, these are all ambulances. These are all scaled down ambulances. As you could see from the picture, moving through the corridor back and forth by giving way to human resources, by giving way to each other, by avoiding collision with any dynamic obstacles, and then reporting the travel, maybe the trip maybe between ICU to reception or ICU to pharma, ICU to store, ICU to laboratory. So it also after dispensing or after handing over, after delivering the item, it will also inform them verbally that for which purpose it is here. So likewise, they can completely integrate it with the existing human workflow. So we started integrating it And it is a long-term process. You have to collect the information with the help of information in the sense like the trajectories, the speed at which the items are carrying, the urgency, the peak time, the stop points, just be taken at one place and then to another place. So all these things are tracked with the help of active or passive tags, and these trajectories are studied, and then the robots are introduced one by one. So the robot is also working based on machine learning. So in the long run, it will act more intelligently. And it is also able to access the elevators, because some of the departments you have to travel between floors. So it has to access elevators. So we have to work with the elevator company to do that. So it may be sending a cloud-based function call to access the elevator functionalities. So it's a very interesting use case. Last week we started deploying it. Finally, we are also, this is actually patented by us. This is a very interesting concept called robotized intensive care unit. Here actually the robot is not just a single or standalone unit. It is actually connected with most of the life-saving devices, health monitoring devices through their manufacturers' APIs, so that we can monitor all the vitals of the patients and continuously monitor the patient movements. So this is specifically for isolated, intensive care unit where people with contagious diseases are under critical care. So this can do various operations like, adjusting the trip speed and then regulating valves and adjusting the inclination of the bed, various things it can perform. And it can also provide physical assistance to the patient through bag drivability. That's another thing which we will just mention after this. And then it is also able to decontaminate by itself. It can serve food, medicine, and it can engage people, because, for these kind of treatments, they are actually isolated. Obviously, they are alone, and they are mentally, they will really feel lonely if they're alone, when they're alone inside this ICU. So the robot can actually engage them, talk to them, show them news clips, and play songs or crack jokes. Anything is possible. So we support that also. This is actually not yet implemented. Many of the trial runs has been already done, but finally this will be, I think, one of the first robotized ICU, probably for the first time in the world. So that's all about this use cases. And finally, I don't have the slides. I will just touch base with another use case, that is obviously surgical robotics. Surgical robotics, you know that it is getting very popular. Da Vinci robot from Intuitive Surgicals are very popular. You are able to perform minimally invasive or laparoscopic surgery with the help of this robot. So this robot has got 5 arms, which is getting coordinated inside the body. But because of certain patenting issues, like the way it is patented is very, very wide patenting, that they have done, so that there are many robots in this area, but soon it will be lifted and lot of products are going to come up. So we just started doing research in this direction, and we are actually addressing 2 issues. One is called craniosynostosis, which is a Weber problem of premature suture fusion. So which is typically done as an open surgery by removing the skull, which we, the forehead is separated, and then it is the sutures are accessed to that. But because of this surgery is done below 1 year of age or 1.5 years, the blood loss is very critical. So we are trying to get this done minimally invasively with the help of cutter and navigator and camera integrated system inside the scalp, and then guiding them externally through the help of a magnetic coupling with the help of a compliant dexterous robot arm. And that is one project. We call it as CranioBot. And then there is another project which is happening is for assisting laparoscopic neurosurgery as a study platform. So I'll just try to mention it. How does it work? One of the key aspects of the collaborative robots. I think the world is actually, the robotics is moving from, as I told you, standard use cases, well-defined, structured use cases to unstructured, dynamic use cases. So wherein it has to work alongside with coexist and cooperate with human beings. So physical interaction is very important. So you shouldn't, first of all, you shouldn't get hurt by colliding with the robot, or a robot should not get damaged, and you should be able to train the robot with ease, and you should be able to get the assistance of the robot. So wherever, as I told you, if you look at post-pandemic, we are always trying to minimize the human involvement. So in case of collaborative robots, collaborative robot manipulators, two technologies are very important. These technologies are actually helping to get these necessities addressed, as I told you, interaction. One is backdrivability. Backdrivability is the ability to take the force, to see the external force in simple way, to absorb the force. Like if two people are shaking hands each other, you can see that they're exchanging force. Likewise, if you interact with the robot, you should be able to take your force. If the external force is air, it should move towards that direction. If the force exerted by the robot arm is air, the entire thing will move towards that. So it's very compliant. So in order to do that, you have to take the external torque inside and then working. Work in accordance with that, or to comply with the human movement. So this backdrivability is used for that. And second thing is, like, it has to balance the self weight. Like if you try to drag the robot, it will just move. As I told you, it will come towards wherever you are dragging it. And then it will also, if you release the hand, it has to stay there, which means that it has to self-balance. So this is done by calculating all the joint forces acting towards the gravity vector and then compensating for that. It won't compensate, which means that if you just fly the end of it in 3D space, it will move accordingly and it will stop there if you release. So this is what we use for this laparoscopic neurosurgery study platform, where an adapter is attached to the tip of the robot, and then the surgeons can align this around the skull in whatever inclination and position he wants, and then do fine maneuver to perform the surgery. So this is all about, there are a lot of other applications, but this is all about what we do, and then there are different possibilities, and I think that's it, and I will show you some of the videos and then actually start addressing the questions.
Sir, here are some questions posed by the participants. So they have asked whether you're working with any micro or nano robots which deals with in vivo solutions.
1 second, don't you need to see the videos? You want to see the videos?
Sure, sir, I can present.
Yes, sir.
But it's not visible, sir.
Yeah, I know that. I'll just share that. Let me open it.
Where do you live?
I'll share. Can you see the screen?
Yes, sir.
So this is not only the medical application, most of the cases are here.
I am living in Kochi. How long have you been in Kerala? 2 years. honorable to prosperity.
This is Karmi bot,
I am ready for duty.
which I spoke about for serving COVID patients. So there is an interactive screen.
Keep me at home
There is an
position.
app also
Hope the
available.
boxes are filled. Press the buttons for selecting rooms. Karmi bot on duty.
One way of using it. You can load the trace and you can send the route. We are not allowed to take pictures from the hospital, so we just took it from our facility. You can see what happens. Through the application.
Please take the food packet for room number 1 from the tray. If needed, caregiver may contact you over Skype. Else, you can talk to me for 2 minutes. Hello. Hello, doctor. How are you? I'm fine, doctor. Do you need something else? Nothing. Everything fine. Happy to serve you. Please press the go button, if any, in the bottom. Kindly place trash, if any, in the bottom container.
This is a disinfection machine. Now the box is opened, the UV is cut, and also while the robot is upstairs, the UV is cut. UV is only enabled when the robot is moving and the box is closed. Patient need not touch the robot.
UV disinfection started. Please don't open the tray. Service completed. Disinfection stopped. Now you can switch off and clean me.
This is the sprayer. You can see that the disinfectant is being sprayed. This is the awareness robot.
There are several measures you can adopt to protect yourself and others from getting the new coronavirus. Frequently clean your hands by using an alphabet product like gel. Burn your hands and sanitizer kept on the table.
Same robot inside performs the screening.
Coronaviruses are a large family of viruses which may cause illness in humans or animals. In humans, several coronaviruses are known to cause respiratory infections. Covered coronavirus.
This is the temperature screening. Earlier we did the temperature screening with the help of device. Now that it is
Please stop there. Hi, hello. What's your name?
My name is Gio Matthew, 28 years old.
Your phone number?
9345-33216.
Please position in front of the camera to check your body temperature. Your temperature is measured as 101 degrees Fahrenheit. Do you have any specific symptoms like throat pain, cough, or cold?
Yes, I have cold and fever.
Okay, I have done with your screening. You will have to consult with Dr. Your current details have been sent to District Health Administration. You may receive a call soon. Hi there. Kindly wear masks to prevent the spread of COVID. Now, I will measure your temperature and dispense sanitizer. Kindly wait.
Now you can see this red, this black spot on the left hand is before any
Your temperature is normal.
This is the inter-hospital logistics robot. I'll also show one more small video.
Sorry for the interruption, sir. Actually, your voice is getting feeble.
Okay. Can you see the screen now? Hello?
Yes, sir. No, it's audible.
Okay, I think that's it. We can start answering questions.
Sir, here are some questions posed. Actually, they are asking whether you're working in micro or nano robotics in vivo solutions.
Micro or nano robotics?
Yes, sir.
We are not into micro nano robotics as of now. But as far as this craniofacial surgery is concerned, we need to do that. In the first phase, we are actually doing it at 1:10 scaled up. Because we have only 18 mm maximum 18 to 18 mm opening, through which we have to put through this systems, which includes the navigation, the cutter, the irrigation, camera lines, the tractor. Everything should be less than one centimeter sphere. So at that stage, we definitely have to do that. So that we are doing as two different stages. We are not accessing or availing any facilities for miniature fabrication. Those kind of apps are available outside India. We will soon do that after the first level of testing. As of now, we don't do.
Sir, also another question about the environmental restrictions with respect to the usage of robots.
There is no environmental restrictions regarding the usage of robot, but there are restrictions for medical applications wherever the robot actually interact physically with the human beings. So that is obvious. So we, in our applications, we keep it aside as an additional functionality, which may have to go through regulatory aspects. Like earlier, a recent policy amendment by Indian government allows us to perform even surgeries. So previously FDA approval was very much required. Now that is being lifted, I think. So it does require certain approvals even then, but not FDA approval. So we are able to perform cadaver surgery, which means that surgery on dead bodies and then human trials. So some policy amendments are there, which is very much in favor of this kind of research activities.
So another one, will the service robots be affordable for poor people living in underdeveloped countries?
Definitely, yes. It's just like computers, because that is something which we wanted to, companies like us always have been escalating to the authority. Because there are three things which comes as major components. One is the actuator, second is the battery, third is the computational platform. So computational platforms are getting very powerful and compact and cheap. That is a good thing. As far as actuators are concerned, actuators has to come from outside India, so that I mean, the percentage of duty imposed also is at present high. Probably we don't have the right tariff for calculating the duty for this robotic spare parts. So they attract maximum duty. I think if that is addressed, and also indigenously, if you are able to develop actuators, and in future, definitely due to mass production, even if the two things we are currently trying to do on these lines is the mass production. Because when these robots are being mass produced, we can definitely negotiate with the vendors against the MOQs and then provide components at a very cheap rate. So which could anyway give you 40 to 50% slashing of the price. And then standardize and make it very specific to address the requirement. I think it is going to be very cheap and it's going to be very affordable. But as far as the immediate requirements are concerned, most of them are B2B requirements. Like we are actually giving it to hospitals, no? So they are all able to afford this, and it definitely shows the ROI in case it was done by a human being. You have to pay salaries. So I think B2B market is already ready for this. But affordability, like if you want to have a robot at home, that may take some time, definitely, just like computers.
So another one, how fast are AI robots in learning accents that people have? So they are asking about the accents, how a robot will acknowledge the accents people have.
That is another area. NLP is getting advanced day by day. In fact, 2013 we had tried to control a robot using verbal commands, if I understood your question correctly. So that is the success rate was very low. Now the success rate is very good. I mean, a lot of people are working on that, and including the local languages. So I think that is a completely different standalone research area. So whenever that is getting matured, all this advancement will reflect in our technology also. So I think if you are able to speak with your mobile phone and order things, you will be definitely able to speak with your robot. Nothing stops. We also use Google. We use subscription from Google for the speech engine. So whatever Google develops, that is applicable to us also. So I don't think it's a problem. It's getting very much advanced nowadays.
Another one, how to manage, what are the measures to manage robotic hazards?
Like what?
Like malfunctioning during spontaneous malfunctioning and all.
See, that's a very interesting question. Spontaneous malfunctioning is a big problem in terms of surgical robots. As far as the other types of robots are concerned, it is not a very big issue. Like it stops functioning, then you have to do it manually. That's it. But in case of surgical robot, if something happens on the go, it's a big problem. So there are currently certain measures that, say for example, in case of this craniofacial surgery robot, we are introducing the cutting device through this small opening, and we always connect it to a thread or by which you can pull that. So the mechanism collapses, and then it becomes the form factor changes, and you can pull it back very easily. So likewise, there are various aspects you can by which you can protect from running into a big problem. So that depends on the use case. I was just giving you an example from this surgical robot. In other cases, it can take a safe position. It can safely retract. It can be inactive, and it can hold the object. Let's say, for example, if you're handling an object, let's say if you are doing a pick and place operation, very simple pick and place operation, the worst thing which can happen is that you drop the object. So if the robot is able to address that situation in a way that wherever it is there in moment in an instant, if it is able to maintain that, including the gripper position, at least your payload is safe. So such kind of precautionary measures can be taken while you work with this kind of robots. Other than that, you have to give me examples wherever you feel that there is a problem. I can tell you how to address it.
Another one is like how discarding robots, whether it can be recycled, what are the proper management? That's the another question.
Yes, that is something which material science has to address because it's again electronic waste. You know that electronics waste is a pressing problem. So it's not just because of robot, any machinery, anything which any kind of, even if it is automobile itself is becoming a robot now. All these automobiles are self-driven robots, like autonomous systems. So wherever electronics are there, wherever machineries are there, this problem is there. So that is applicable to robots also. I think that is a problem which has to be addressed with the help of material science to minimize the usage of non-degradable products or materials. So that I don't see that as an isolated problem only connected to robotics. It's a very generic problem. I think we have to address it.
Thank you, sir.
Any other questions?
The rise of service robotics during the post-pandemic era, which throws light on the future scenario of how robots would be incorporated in human world as cobots. We extend our sincere gratitude, sir, for your insightful session and imparting your knowledge and experience. And we look forward to have more discussions with you in future. Thank you, sir.
Thank you very much. Thank you, everyone.
Thank you so much, sir, and thank you, Kamalam. Next we'll be playing the podcast made by the third years of bioengineering students.
Hey everyone, welcome to the first episode of our from the very depths of hell, hosted by Vishuta and Archana. What's in the air?
Come on now, Archana. SCBD might not be the most fun department in existence, but it certainly is no hell, right? Well, it might be if hell was sold in a discount sale.
Wait, who's the mean one here now? Anyway, without further ado and with the holy spirit of meanness on our side, armed with brutal scientific facts, let's invoke the beginning of our pandemic podcast, What's in the Air?
This topic has sparked wildfires throughout the world, quite literally, and it still remains one of the hotly debated topics of this COVID pandemic and the one before it too, the Spanish flu.
That's enough foreplay from you, Vishuta. Masks. Yeah, that's our topic, masks. Can you believe it? There are questions about the protective effectiveness of masks even now.
That's right, Archana. You know what really is in the air besides COVID and over-the-top TV shows? Frustration, doubt and anxiety. Always has been.
On the flip side though, introverts are enjoying the anonymity masks give them, and even without the obvious safety reasons, people have begun to wear masks in their day-to-day life as a fashion statement.
Yeah, I do agree. So let's dive into the most polarizing topic of this year. Wait, no, that's not the Bollywood mafia, it's not Bigg Boss either. It's masks.
every single day you can see people going about the street wearing masks of different color, different material. Some even wear plastic containers over their head and some with self-made holes in them to breathe.
It was at this moment that he knew. He thought.
You know what? When you say it like that, it really makes you wonder what actually are the types of protective coverings you can use. And I know people who wear kerchiefs over their mouth, it doesn't make you look bad as nor does it protect you.
That's a lot of damage!
Here's a wacky fact for you, Vishita. Each person has a unique sneeze, but this doesn't really matter. Either way, it can easily spray droplets to more than 8 feet.
So this fact alone makes social distancing useless when in the range of an infected person.
This is no time to get flustered or jump to conclusions, right, Vishita? Protection from the infected person is what exactly masks are for, yeah? Care to elaborate on the type of mask now, Vishita?
Oh, got carried away for a second there. So yeah, masks based on their making are of two types: the homemade masks and industrial grade ones. Homemade masks are widely available and their fabric is mostly dense cotton. Cotton, if you see, can decrease the projectile spread of nasal droplets to a mere 2 inches. That's amazing, right?
Wow, I didn't know cotton masks were that effective. The other day I found out that old t-shirts are being recycled to produce masks. Isn't that a neat idea?
Hold up, Archana. The idea of t-shirt masks seems appealing and all, and they are cheap too. But they are only 1/3 as effective as surgical masks, you know.
Obviously, surgical masks are better, Vishita, but not all of us can afford them, right? See, that's where cloth masks with filter come in. Although not as effective as surgical masks, they are much more effective than regular cloth masks. You can even use a tissue paper between your nose and a regular cloth mask to emulate the effect of a filter, you know?
Oh, that's nice to hear, Archana. And have you heard of neck gaiters? They are a tube of cloth fabric worn around your neck that can be pulled up or down whenever required. But when used as a substitute for masks, this synthetic fabric doesn't actually offer much protection, sadly, for people who want to look fashionable.
I didn't know about them, but I did see people wearing them. I guess that's everything about homemade masks. Now, let's jump into the industrial grade sweet science stuff, yeah, people?
About time we did, Archana. Now, it's question time, people. Are masks and respirators the one and the same thing?
Wow, that escalated quickly. Obviously, the audience cannot answer now, so let's turn to our very own Computer G to answer this question for us. What do you say, Computer G? Is it a yes or perhaps a no?
Wait a minute. Who are you?
Computer G? It's not Xi Jinping's AI version or something, is it? Well, we'll find out soon enough once he answers the question, I guess. So what is it? And yes or no?
Of course, the answer is no, dumb.
Well, there he is, mean and unforgiving as he always is.
I imagined worse, but we can make do with him, I guess.
So my point is, masks and respirators are two very different things. Industrial grade masks are mostly used in performing surgeries and therefore used for medical purposes such as disposal of biohazardous waste material.
And there are respirators, on the other hand, which are used in metal-based industries where workers need protection from the toxic vapors.
Besides the apparent differences in areas of usage, they are fundamentally different in the mechanism and the scientific principles employed to protect the wearer.
Yeah, you're absolutely right, Archana. To actually explain better, masks are a category rather than a standalone equipment. Masks can be either surgical masks, which are disposable devices, and there can also be respirators, which are personal protective equipment worn in hazardous conditions or around people as well.
What's the big deal about the difference, one might ask? It does make a huge difference whether you wear a surgical mask or a respirator. This is because surgical masks are meant to protect the people around the wearer in addition to the wearer himself. They're not particularly effective in protecting the wearer against airborne viruses such as the smallpox virus, for example, but it does completely trap the respiratory particles exhaled by the wearer.
As to the science behind it, surgical mask works based on electrostatic attraction exhibited by bacteria towards the mask surface. So it can be very effective against bacteria, you see.
And then you have respirators. If you remember in the beginning of the pandemic, there was a huge buzz about N95 masks and people were trying to get their hands on one somehow. What exactly are N95 masks and how do they work? You may ask. Well, that's your cue, Vishita.
Why? Thank you, Archana. Respirators, you see, mainly work by filtering the air the wearer breathes in, by trapping the hazardous substances trying to make their way in. And those who think they are wearing N95 respirators when it is only some cone shaped mask with N95 printed on the fabric, I hate to break it to you, it doesn't protect you as the same way a respirator would.
Well, there are different types of respirators too, from what I've heard. You have the most basic ones, which are particulate respirators, and N95 masks are also particulate respirators. And they actually purify the air up to 95%, and this is a reason why they are used in hospitals so as to protect the wearer against viruses. And you have other masks such as gas mask respirators, which protect you from toxic chemical vapors, and powered air purifying respirators, which have a fan to draw air into the mask, which makes it easier to breathe apparently.
And there's another interesting type of respirators which are self-contained breathing apparatus, SCBA, used by firefighters. You don't even need a filter in that. They also have they have built-in tanks to supply oxygen to you.
So basically, it's the big tanks used in scuba diving, isn't it?
Yeah, only that you're diving into an ocean of fire that is.
That got dark pretty quickly. So, with the type of mask explained and sorted out, let's jump into the glaring flip side of our science topic, the anti-maskers.
This is America. Don't catch you slipping now. Don't catch you slipping now. Look what I'm whipping now. This is America.
Okay, let's not beat around the bush on this one. Everybody has been harping for some 6 months about how important it is to wear a mask. But most of us do not even know why or how we are supposed to follow that advice.
Slow down, Vishruta. This segment is going to be a slow simmering roast of those who neglect their own safety and put others in danger as well. We are going to tell them why it is they need to wear masks.
Firstly, we need to find the origin of these ridiculous myths and conspiracy theories and where they spread from. It's something we use every day. Of course, you know what it is. It's our very own social media.
Speaking of social media, the whole Flat Earther movement gained a record number of followers than it ever did from the time it was founded, just because it entered Facebook some 8 years ago. This just goes on to prove how social media is not just a means of connecting with people or sharing knowledge, but it also is a cesspool of circulating conspiracy theories that seem to have no basis to them whatsoever.
Archana, who needs to slow down again, huh? Well, I cannot blame you for getting all riled up, since it really is a polarizing issue played for politics all around the world, especially in the most powerful nation of the country, the USA.
You're right, Vishruta. On one hand, you have Alex Jones, who you definitely need to Google ASAP, people. This guy basically said 5G caused the pandemic, and you won't even believe it, Vishruta. People actually took to the streets and burned down some towers. Crazy stuff. On the other hand, you have Baba Ramdev, who reportedly found a vaccine to COVID.
The blatant ignorance of anti-vaxxers who advocate against vaccines because they think it causes autism and mental retardation, and they fuse adherence to this quack theory stupefying to a normal human. But you know where it gets really scary? It's actually when these people storm the capital of a state in the US with guns against lockdown and protective measures and accomplish what they said to do in the first place: anarchy against basic science.
It is scary, Vishruta, now more than ever. Weaponization of conspiracy theories and inciting disorder is rampant, and it is the easiest it has ever been just because of social media.
But there are people who are genuinely unaware of why they are told to wear masks, and I suppose it is our duty as a common fellow citizen to inform them why calmly.
I suppose you're right on that one. Why should we wear masks, people? Is it to protect our own self, or is it perhaps to protect others as a form of altruism?
To be very honest, the correct answer is both. You have the basic right to protect yourself from external danger, but at the same time, you should not violate the same exact right of the person standing next to you by not wearing a mask.
You couldn't have worded it better, Vishruta. That's right, people. We do not want to come across as high-strung or incite hate in your minds. We just want everyone to be healthy and safe.
And wearing a mask is only a slight inconvenience compared to wearing a ventilator, people.
If I remember correctly, there was a Republican senator who told the press that he wouldn't wear a mask because Man was created in God's likeness and it would be a disgrace to cover the face of oneself. I gotta tell you, he is a clever man. He knows he has enough privileges to protect himself, and even if he did get infected, he is still going to go to a good hospital with good health insurance.
Oh, but the downtrodden people, like people who are religious and exploited for votes in the end and are egged on to endanger their lives and others. That's the flip side of this whole mess.
People, the ones who don't wear a mask, at least have someone to blame, like Bill Gates. But those who do wear a mask, not over their mouth and nose, but on their chin, they should go to hell. What really is the use of wearing a mask when you don't even cover your mouth? I mean, it completely defeats the whole purpose of wearing a mask at all.
As angry as it may sound, it's justified. It can really be frustrating when someone does not do something properly, even when doing so is essentially connected to their odds of survival. Now, those who think being told to wear a mask is a violation of your personal freedom, just think twice and think hard about it.
Merely thinking about it is not gonna help. I mean, look at the amount of people that end up in hospitals nowadays. One of those people would have ended up there just because you might have not been wearing a mask. If that isn't gonna help you in culling your self-destructive tendencies, nothing will.
That's enough about anti-maskers and the reasons behind wearing the masks, I guess, Archana.
That was some wild topic, I gotta admit. Well, people, it's about time for us to close shop.
Wrapping up this episode with a one-liner might be cool, I guess.
Keep your hands in the air and your eyes peeled for our very next episode of What's in the Air, fellow humans.
Sayonara and goodbye, people. By the way, Archana, that line wasn't cool at all.
We're not letting you leave just yet, dum-dums. Do not forget about the brains and voices behind this podcast, the scriptwriter, Anirudh, the speakers, Archana and Vishruta, and finally the editor, Srinidhi, all from our very own department, SCBT. Thank you guys.
Hope you guys enjoyed the podcast. Now it's time for some myth breakers. Why don't we enjoy it?
Hello guys, I am Shruti and this is Adityan, and we will now host a short, interactive and hopefully informative session which is slightly fun, and we call this Myths or Facts. Let's debunk.
We will display a few statements and you'll have to guess if they are a myth or a fact. Let us know in the YouTube comment section. Let's just dive right into it. Myth or a fact? Dolphins sleep with only half their brain and with one eye open so they can see for predators. Is it a myth or a fact?
This seems very far-fetched, don't you think?
It really does. What do you guys think? Let us know in the comments.
We're actually eager to know what you guys think. Why not comment if it's a myth or a fact?
We've got some answers saying they are myth. What do you really think?
Oh, there are some people who also think it's a fact. Why don't we debunk this right now?
Yeah, let's get into it.
It is a fact. This type of sleep is known as unihemispheric sleep, as only one brain hemisphere sleeps at a time. Dolphins alternate which half of the brain is sleeping periodically so that they can get the rest they need without ever losing consciousness. So cool, don't you think?
This is really cool. Let me get to the next myth or a fact.
Yeah.
Oysters can change from one gender to another and back again, depending on which is best for mating. This is very weird. Is it a myth or is it a fact?
I mean, why would you change genders from male to female and then back to male again? I think it is a myth. What do you guys think?
Is it a myth or is it a fact?
Please do comment.
There are some people saying it is a fact, and there are some who are saying it is a myth. And some even have mixed opinion. Maybe a fact, maybe a myth. What is it actually?
Let's go debunk it then. See, it is a fact. So all oysters start off as male, but most change permanently to female by the time they are like a year old. Their reproductive organs can produce both sperms and eggs, and they can change gender at their own will. So technically, it is possible for an oyster to fertilize its own egg. Weird.
Do you mean like, are these oysters like hermaphrodites?
Not quite. You're almost there actually. They're actually called sequential hermaphrodites, meaning they can shift their gender from male, wherein they'll produce the sperms, and then they'll shift it to female, wherein they'll produce their own eggs. And this sperm and egg can fertilize, and hence why I mentioned an oyster has the capacity to fertilize its own egg.
I mean, this is very, very, very weird. Okay, let me get to the next debunking. Myth or a fact? A severed earthworm can regenerate into two separate beings.
Oof, I think this is a myth. Not possible.
I think this is a fact.
Really? Let's see what these people think.
What do you guys think?
Fact, myth, fact. So many mixed opinions.
Okay, there are a lot of people who are saying it is a fact. Okay, see, people are on my side.
I'm pretty sure it's a myth. Let's go debunk this. I told you, it is a myth. So this myth is pretty close, but we're not quite right. It's a planarian flatworm, which when cut, can regenerate into two or more new worms. But earthworms cannot. Earthworms have a distinct head and a tail. So when severed, the head can regenerate a new tail, but the tail cannot regenerate a new head. But one fact that you have to take into consideration is that they still have a remarkable ability to generate most of their body if they are injured at any part of their body.
I mean, I really wish this was true for humans. You know, it would be really nice to meet a clone of myself.
Please, I can't stand one more of you on this earth.
I mean, you're just jealous of me. That must be the fact.
Or so you think. Not possible.
Yeah. It's just I'm smarter. Let me get to the next one.
Okay, let's discuss this. I mean, everyone loves chocolates, almost everyone. And we've gone through a phase where we binge eating chocolates and everything. But did you know eating chocolates can actually give you acne?
I don't think I believe this. You see, look at my skin and look at my diet. I eat a lot of chocolates and I have the most perfect skin.
Have you ever looked at your face in a mirror, Radhi?
I just told you, you're just jealous of me. I'm pretty and smart at the same time.
Okay, what do you guys think? It's a myth or a fact?
A lot of people aren't on my side. They're saying it's a fact. What do you think?
I mean, there are people who literally said, I don't want it to be true.
Yeah. Okay, I think we'll have to debunk this. What do you say?
Let's go.
Wow,
oh my God.
It is actually a myth. See, the Berkshire skin is true. For almost 1 month, scientists fed a dozen of people candy bar containing 10 times the usual amount of chocolate and a dozen of other fake ones. When they counted the zits before and after the diet, they said there was no difference. It means like the chocolate or the fat did not have any effect on the acne. See?
Turns out you're smart. But I wish I was one of those few dozen people who got free candy bars for 1 whole month. I mean, so cool.
I would love to be in that too. Let's get to the next one.
So we've all known people who consume mushroom in their diet. But did you know a mushroom exists that outsizes the blue whale as the world's largest organism?
No, mushrooms are teeny tiny organisms like this small. How can it be like outsizing a blue whale?
What do you guys think?
What do you guys think? Is it a fact or is it a myth? Let us know in the YouTube comments.
There is confusion again. There's some people saying maybe, some think it's a myth, but most think it's a fact. And they're pretty sure this time.
I don't know. I just have to debunk it. I'm really sorry.
Yeah,
What?
go ahead.
It is a fact. Estimates suggest that this mushroom is 2,500 years old and weighs 440 tons.
Yeah. So the blue whale generally gets a lot of ink for being the largest animal to ever live, beating out even the biggest dinosaurs. But it turns out the largest organisms on Earth aren't in the oceans. They're just beneath our feet. You know, those teeny tiny organisms that you mentioned?
Okay, stop making fun of me. Let's get to the next one. Myth or a fact? Which of this is true? A person's nails and hair grow even after they die. The body releases methane gas after death. Which of the following statements do you guys think is true? Let us know in the YouTube chat box.
I mean, for everything that I consume, I'm pretty certain my body would release a lot of gas.
What do you guys think? Which one is true? Let us know in the YouTube chat box.
Ooh, so one thinks it's the first one.
And some say it is a fact.
Body does release the methane gas after death. Okay, I don't know.
Yeah, neither do I. So I think we'll have to get to the debunking.
Yes,
But
we
then
should.
there are a lot of people who say first one is the fact, saying that people's nail and hair grow even after they die.
Okay, let's go debunk it right now.
Yeah.
Both statements aren't. So when you die, your skin actually dries up, because of which it looks as though your fingernails and hair have grown and lengthened. I mean, cells can't grow after they're dead, can they?
And even the second fact isn't a fact. It is, you can't just, produce gas after you die. It's just the microorganisms in your body that does that. These microorganisms feed on your body's tissue, ferment the sugar in them and produce gaseous byproducts such as methane, hydrogen sulfate, ammonia, and then all of these accumulate in your body, causing bloating in abdomen usually, but sometimes even in other body parts.
I'm surprised it's not because of all the food that I've eaten.
Now that you're speaking about food, I really want to eat some custard,
So
or some
random.
fruit salad, or some ice cream.
Oh my God.
Okay, I have to go Google some recipes. What do you think?
Oh, wait. Now that you mentioned Google, we actually have a small task for you guys.
Okay, now that we've been talking about food, I want to know which organism or which animal can produce or cook its own custard.
And knowing that custard comes in various flavors, find out from where you get vanilla flavoring. And do let us know what you found out in the Google search.
I guess you will be astonished by what you Google.
Yeah, definitely. But for now, thank you and bye-bye.
Thank you so much.
Hello everyone. So we had the poster presentation competition happening last semester and we have few people to present their posters now. I'll call Aditya and Ajay Pawan to present their posters.
Can you see and hear me?
Yeah, you're audible.
Am I audible?
Yes,
I hope
you
you're
are.
audible. Yeah, all right.
And can you see the screen?
Yes, we can.
Yeah, okay. So, good afternoon. I am Aditya Girish, and with me I have Ajay Pawan. And we did a poster basically researching the different methods to treat cancer, and we found out that the different types of methods exist. Immunotherapeutic methods, and you have interventional methods. You have other methods like chemotherapy, radiation therapy, etc., etc. So our basic idea was, since cancer is still a very prevalent disease in the world, so we thought maybe combining two of these methods might actually result in a very positive effect, an effect which is synergistic, that combines both and actually works on the benefit of each one. So Ajay Pawan will explain the fundamental idea.
Yeah, so the fundamental idea is we'll talk about the two types of cancer treatment which we mentioned here. First one being, so immuno-oncology focuses on stimulating our immune system against various molecular targets using our own antibodies, as in you don't introduce anything else, any other antibodies from outside. So it basically triggers your own antibodies to fight against the antigen. And based on the antigen-antibody reactions, that is the basis of the treatment. So interventional oncology, on the other hand, focuses on destroying the cancer cells, or either directly or indirectly by cutting the blood supply to them, or using radiation therapy, chemotherapy. Although these two methods are pretty good by themselves, putting them together and combining their effects will augment each other's advantage, and this will definitely be a revolutionary advancement in cancer treatment. So I'll also be explaining the principal mechanism of interventional techniques. So basically, as I said, interventional techniques is basically destroying the cancer cells. So one way of doing it is directly killing the cancer cells by radiation therapy or chemotherapy. The second method, embolization, is basically you cut the blood supply by restricting the blood vessels that supply blood to the cancer cells. So in the end, the nutrients don't reach the cancer cells. So in the end, they do die. So that is mostly generally how interventional techniques work. And Aditya will continue explaining about the immuno-oncology.
Yeah, immuno-oncology, you have different techniques where you have where you stimulate the cell to work against the tumor cells. You have dendritic cell stimulation, either by extracting them from the body and then activating them towards a factor that's called the GM-SMS factor. That is it's a factor which stimulates the dendritic cells to present antigens of the tumor cell to our body's immune system. That is one method. Another method is basically we have certain checkpoints in our immune system, certain proteins like CTLA4 or PD1, which actually regulate our immune system. They are released by T regulatory cells. So they keep our immune system under check. And if we somehow toggle that, we can use it to inhibit these proteins from being released. And that's going to result in a much stronger immune system response towards these tumor cells. So when you try to combine these two methods, your interventional method and your immuno-oncological method, you start by ablation first. In ablation, when you directly vaporize these tumor cells, you'll have a lot of antigens being released into the bloodstream. And if you can activate our immune system against these antigens, if we can stimulate them, that is going to lead to our immune system attacking these tumor cells, like I mentioned. When it comes to your embolization, one of the hallmarks of cancer is angiogenesis. So embolization is going to, on the one hand, prevent blood supply and nutrient supply to these tumor cells. And on the other hand, if you can inject any cancer battling drugs, like chemotherapeutic drugs, into this immune system, and you cut the blood supply to them, you're going to be focused with only these drugs targeted to the tumor cells. So all these two methods can actually go hand in hand and improve upon each other's and uplift where one system fails. So that's going to ensure a more a greater possibility of actually recovering from cancer. And now Ajay.
Yeah. So as he mentioned, the two things that he mentioned, you can combine the two techniques. Basically, there is another thing where you can introduce checkpoint inhibitor drugs, which basically enhances how your immune system works, and so that actually helps us. I'm sorry, one second. Yeah, sorry. in regulating the progress of the tumor. So basically, the tumor keeps on growing, and then you don't want it to metastasize. So combining these two techniques, you can actually use checkpoint inhibitor drugs along with interventional oncology, so that you can prevent the chances of metastasis. So on the right side, you have the graph, which basically shows that this is a potential field which is yet to grow. So you can see that there is an increasing market for immunotherapeutic drugs in China, and this is over the entire decade, the past decade. So it gives an insight into the type of potential such an integrated treatment procedure possesses. So few clinical trials have been carried out to determine the best combination of methods to treat particular tumors. So one such example here is basically if you combine cryotherapy with checkpoint inhibition, it has been proven that it is very effective against NSCLC, that is basically non-small cell lung cancer, and metastatic melanoma. At the end of the day, then this is one of the slight disadvantages of this technique. You do not have a preset procedure. I mean, you have a generalized procedure, but then the most effective procedure is very patient specific. So that is, at the end of the day, it is very patient specific, and every patient should be treated accordingly. So conclusion, I think you can take over.
Yeah, like he mentioned, it's very patient specific. It depends on the immune system of each patient, and we'll have different results for different types of cancer and different stages of cancer. It's definitely a field with potential, but then you'll have some side effects which have to be dealt with. Like, for example, when you're subjecting this kind of treatment to a patient, this is it's very effective. Like, what do you say? It's very intense. You're going to have a lot of side effects, and it might lead to a few drawbacks. That's something that still needs to be worked upon, but in future it could actually result in a good therapeutic method to treat cancer. I think that's it. Great.
That sums it up.
Thank you, Aditya, and thank you, Girish, for your presentation on immuno-oncology. Next up, we have Tanushri and Aishwarya to present.
I'm Tanushri, and we are here to present our poster on the captivating CRISPR-Cas9 technology. So CRISPR, standing for Clustered Regularly Interspaced Short Palindromic Repeats, is a unique technology that enables geneticists and medical researchers to edit parts of the genome by removing, adding, or altering sections of the DNA sequence. The basic idea with which this particular technology works is that it cuts DNA at particular points and then allows the natural DNA repairing mechanism in our body to take over. It has been observed that there are two key features of CRISPR-Cas9 that work hand in hand to make this possible. One, the CRISPR-Cas9 enzyme behaves as a molecular scissor that cuts two strands of DNA at specific locations in the genome. This will enable us to either add or remove bits of DNA. Two, a long RNA strand that binds to DNA. This long RNA consists of a small pre-designed RNA segment of about 20 bases long. This small RNA strand is referred to as the guide RNA or the gRNA, as it guides the Cas9 enzyme to the right part of the genome, thereby cutting it at the required location. Once the DNA is cut, the cell's own DNA repair mechanism takes over to add or delete pieces of genetic material or to make changes to the DNA by replacing an entire existing segment with a customized DNA sequence. Now, I would give the presentation over to my teammate Aishwarya.
Aishwarya, can you please unmute yourself?
I'm so sorry. Okay, so am I audible now?
Yes, you are.
Okay. Okay, so we'll now look into the three main types of gene editing, which is facilitated by the CRISPR-Cas9. They are disruption, deletion, and insertion. First up, we have disruption. When a single cut is made, it results in NHEG, which is non-homologous end joining. These eventually result in addition or deletion of base pairs, which disrupts the original DNA sequence, thus the name disruption. Next, there is deletion. Deletion is when a part or sequence of DNA is deleted. This is facilitated by two guide RNAs that target the separated site, and NHEG will then join the ends, thus deleting a fragment of DNA. On the other hand, when a new DNA template is added, it's called insertion. Insertion allows room for correcting a gene via a process known as homology-directed repair. So these are the three main types of gene editing mechanisms. Tanushree will now talk about the concerns related to the CRISPR-Cas9 technique.
So, owing to the fact that this technology has seen tremendous progress in vitro and more recently in vivo, we can proudly say that it holds a great promise for future clinical translation. Yet, no invention or discovery in healthcare could be encountered without ethical concerns. Though most changes introduced with genome editing are limited to somatic cells and affect only certain tissues and are not genetically passed, however, changes made to the germline cells or in the genes of an embryo are genetically passed to the future generations. This brings up a number of ethical challenges. Would it be permissible to use this technology to enhance normal human traits like one's height or intelligence, or to get rid of genetic disorders completely? It is for us to decide. Thank you.
So we have a few applications of CRISPR-Cas9 here. The first is gene silencing. CRISPR-Cas9 allows silencing of a gene without permanent knocking out of the gene. The Cas9 nuclease will physically block the RNA polymerase and inhibit gene transcription, thus silencing the gene. The breaks in the sequence, if made, are then repaired via the NHEG. Next, there is DNA-free CRISPR-Cas9 gene editing, which enables gene repair, wherein no CRISPR-Cas9 component in the form of DNA vector is used. Instead, the Cas9 mRNA or the Cas9 proteins behave as the source. This is because DNA-based Cas9 carries with it undesirable alterations at the cut site. Not just this, these two, CRISPR-Cas9 has various other applications, such as CRISPR-Cas9 mediated chromatin immunoprecipitation. Then we have transcriptional activation and repression, live imaging of DNA or mRNA, and therapeutic application. This is with the application part. I would now like to conclude by saying that with all the above discussed mechanisms and applications, we can definitely say that CRISPR-Cas9 has the potential to become a reliable genetic tool. Though further research and studies are necessary to improve the performance, it opens the door for various passive gene editing mechanisms. Thank you.
Thank you, Tanushree, and thank you, Aishwarya. Next up, we have Shringa's presentation.
Good morning, I'm Shringa from third year bioengineering, and the topic I've chosen for the research article presentation is induced pluripotent stem cells in inherited arrhythmia syndromes. Okay, so inherited arrhythmia syndromes they'll contain an array of diseases which include long QT syndrome, cardiac myopathies, and Brugada syndrome. So what actually happens here is there is going to be an irregular heart rate. The heart rate is either going to be too fast or too slow. That is, their rhythm is going to be impaired. It is going to be improper. So that is what happens in these cardiac arrhythmias. And why are they severe? Because they are going to cause sudden cardiac deaths, especially in individuals who are young and in young adults. And also the treatments we have as of now for these arrhythmia syndromes
is only going to aim at reducing the symptoms of arrhythmias and what can further be done after the damage has occurred. What can further be done? They only concentrate on these. But because we don't know what actually happens in the cellular level of these arrhythmias, we haven't found a perfectly proper cure for these diseases. And also there have been a lot of animal studies, but again, these have proved to be, as much as these have proved to be useful, there are going to be a lot of differences in the species level, because the cardiac myocytes which are present in them and which are present in human beings are going to be having a lot of species differences. So this is also a major barrier. And tissue samples cannot be easily obtained because we can't really obtain these heart tissue samples from patients or even from other healthy individuals to study them. So we have all these problems, and this has led us to find some new technology where we use induced pluripotent stem cells to study these arrhythmias. So how do we do this? What we do is we take induced pluripotent stem cell derived cardiac myocytes, and we derive this by the simple reprogramming method, like how any other induced pluripotent stem cell is reprogrammed. So this has actually proved to be useful in the last few years because we can say that this is going to give a kind of a personalized medicine. It is a personalized medicine because we don't need to depend on a donor. There's going to be no immunorejection. It can be directly taken from the patient, and we can have specific cardiomyocytes which are specific to the patient. So they are useful in that way. And also, once we obtain them, we can do a lot of studies with them. We can do calcium imaging, we can study them electrophysiologically. So by all these studies, we can see what has actually gone wrong in the cellular level that has led for that patient to have the arrhythmia. And also we use a lot of genetic variations by CRISPR technique, where we induce these genetic alterations in cardiac myocytes, and we see how these cardiac myocytes function with this genetic variation. So the major problem statement here is there is a very ambiguous pathophysiology for these arrhythmias. We first don't know what is happening in these arrhythmias, what exactly has occurred in the cellular level, and what can actually be done after that. So with that problem statement in mind, we are going to see a few objectives, where the first objective is to study the cellular level abnormalities which are present in arrhythmias. So to do so, we first require these somatic cells which have been almost completely differentiated. We take them, we reprogram the cells, and then we obtain induced pluripotent stem cells, and then we have to next obtain cardiac myocyte which are specific to the patient by manipulating. And also, after obtaining these cardiac myocytes, we have to now analyze these cardiac myocytes by different methods to see what has actually gone wrong. So I would say that the possible therapies, that is the most important step for these or that's the major goal for why we are doing these things. So to obtain or to achieve the possible therapies that can be implemented, we first have to know what the actual cause of the disease is. So as much as this is the
On Monday, June 5th, 2017, I felt the worst headache in my life, like an ice pick driving through my skull. A CAT scan revealed a bleed in the side of my head, the size of a softball. The only option to stop the bleed was to have a craniotomy to remove it. Being completely out of control is terrifying.
It's difficult to talk to patients about brain surgery because it's very abstract. We're combining delivering difficult news about a scary diagnosis with the additional fear of not knowing what to expect and not being able to understand what it is I'm explaining to them. When we show them the model, when they fly inside their own brain, they can see the structures, they can see the tumor, they can see the aneurysm.
This device creates an experience for the patient where nothing is unknown anymore.
Well, it's certainly daunting to think about somebody tinkering around inside your head. There's a whole bunch of anxiety that comes with that. Patients are looking for some hope. They're looking for a way to understand what's happening. What's made brain surgery historically pretty challenging is surgeons have to look at two-dimensional imaging and then in their mind's eye create a three-dimensional map of how they might approach the operation. We thought, you know what, we can intervene here and we can take MRI and CT scans and fuse them together in our software to create a virtual reconstruction and change the practice of medicine for the benefit of the family, the surgeon, and the institution. It is that person's anatomy VRalized. The Intel processor really allows our content to come alive.
We've worked with surgical theater, taking our latest desktop and notebook processor technologies so that we can very quickly render those 3D environments in the exam room and allow that patient to have a real-time immersive experience while their provider's in the room.
Hi there. Good morning. Good to see you again. What you're looking at now, this is a three-dimensional model of your brain. You see the tumor there in green?
Yes.
Now you're getting something to see that most patients never get to see.
I was totally panic-stricken. I'm not a doctor, so I couldn't understand what they were trying to tell me because I had never physically seen a craniotomy before. It's so hard to wrap your head around what they're about to do. When I put on the goggles, my surgeon asked me if I was ready to fly. In the moments where they were telling me really terrifying things, I also felt a little bit of peace from the way that it was being presented. I was able to, in real time, see inside my brain. I was physically there with them, looking at exactly what they were trying to communicate.
Before surgical theater, preparing for surgery was literally me sitting over a cup of coffee, kind of thinking, okay, I'm gonna do this. And then I remember that the optic nerve is here. But those preparations were a kind of ad lib. Now, with 360-degree 3D reconstructions, we're able to be inside that environment, which is as close to brain surgery as we can actually get without being there in the operating room. The advantage that the virtual planning and rehearsal brings to our readiness for surgery is the ability to simulate multiple different approaches. In a real patient, we don't get to try that more than once. We only get one shot at it. In the virtual model, we can do 2 plans, 3 plans, 5 plans, and see which one is the best for the individual patient. Make the bone look a little more like bone, so it's not translucent at first. Now that I can see the frontal sinus, I'm planning it, differently. Yeah. Let's bring in the microscope. When we're in the operating room and we get to the time of surgery, because we've done the preoperative rehearsal, it kind of feels like deja vu. Like, okay, I've been here before. I know where the important structures are going to be.
Sarah, here we are. We're coming up to the back of the tumor right here. This would be a good place to do an overlay. Make the tumor more translucent.
I was at the hospital in the ICU for 10 days, and I had 2 angiograms, 2 MRIs, 2 CAT scans, and a craniotomy. I had a risk of having epileptic seizures for the rest of my life, not knowing that I'd ever be able to drive a car again, that I would ever be able to run again. But I would say the biggest testament to how everything went was the fact that I'm sitting here today. It was nothing short of a miracle.
I think this technology is absolutely groundbreaking. I wouldn't use the word revolutionary. I would say it's evolutionary. I think virtual reality will change the face of healthcare. I think in some ways it already has. This is just an expertise that Intel possesses that has helped us advance in ways we never thought possible. People are demanding transparency. I think people deserve to be spoken to in a way that they can understand.
It made me more grateful for each and every moment that we have. We experience life in 3 dimension. Why should our medical care be any different?
So we have a couple of case studies here. See, if you guys know the answers, put it in the chat box. A
These
kid
are
with
medical.
20/20 vision and perfect good eye always gets into bikes when playing and perceives moves and cartoons frame by frame. No previous medical condition. What do you think this case is?
If you have any doubts regarding these questions, you can post in the chat box so we can find out what disease these are. Diseases or conditions these are. Do you guys have any idea what this might be? Let me read this case again. A kid has a 20/20 vision and a perfect good eyes. This means he's able to see everything perfectly. So that is, his vision quality is really good. But then he always gets into bikes or like when moving or gets into cars or anything. And he says that he's able to see every TV show that he sees by a frame by frame. The person has no medical conditions, no previous medical conditions. Do you guys know what this condition might be?
Any guesses?
We are getting chat box replies such as Jamis, Wu, and Mania. But let's find out what this case actually is. This condition is called achinotopsia or motion blindness. That is, this person, we are getting a chat box saying, is that person dreaming? No, that person is actually not dreaming. The person is awake and is conscious. So what happens is, in case of motion blindness, you'll not be able to see pictures in a continuous way. That is just like going to be a case where you can see like tube lights blinking. That's how your entire vision is going to be. Let's go to the next case. This one is a really interesting case. A patient after a cardiothoracic surgery visits a doctor for checkup. His vitals are completely stable. He has a very strong pulse in the arm and his blood pressure is really good. But then the doctors are not able to find the heartbeat. So let's get into the patient's history. So this patient had a pneumonectomy and has been a continuous smoker for 5 years. But if you look at his lifestyle, you can notice that this guy is a truck unloader and then he had a very healthy diet. So what happens in this case? What is really the problem? He has a good blood pressure. He has a very strong distal pulse in the arm and his legs, and his vitals are completely stable. And then this person is here after a cardiothoracic surgery for a checkup. What do you guys think this condition can be? Or what might have happened here? Absence of valves. Let's say if there was an absence of a valve, we'll not be able to get the pulse at every posterior ends. Something caused due to the surgery. I think you guys are very close to it. Let me explain why it cannot be absence of valves. Say if there was absence of valves, we'll not be able to get the blood flowing out in entire proper fashion way. So it is not going to be. Heart is in the right side. If the heart were in the right side, we would have known it when there was this cardiothoracic surgery. And it would be the same doctor who does the post-op checkup also. So that's not the right answer. I think we'll have to get into finding out what this actually is. Let's see what the answer is now. His heart fell out. This is a very, very extremely rare condition where people reporting these cases is very low, but then his heart actually fell out. The space between the lungs and his heart had to do something. Yes, actually. So after this pneumonectomy, what happens is they remove a lobe of your lung. So what happened is the heart that was supposed to be right there fitting in the chamber fell outside into the abdomen region. So you will not be able to find a very strong heartbeat where you are actually supposed to. So yes, his heart fell out. And this is called post-pneumonectomy syndrome. Let's get to the next case. This one is a really good case. So what happens is there's an art teacher who works in a school. This teacher complains of headache and eye strain. So this teacher is now visiting an ophthalmologist. Once again, a perfect 20/20 vision. But then this heart teacher started to feeling like heartburns and then heart failure. One by one, it started leading to multi organ failure, which was mostly related to gastrointestinal organs. What if you have to look at the medical history? This teacher had an appendectomy when she was in her early teens. Now, what if you look at the lifestyle? As mentioned, this person is an art teacher, and she's very much interested in pottery, and she's a person who loves doing ceramics and owns an art studio. I think the lifestyle will give you here a very brief clue about what this can be. Any guesses, guys? You can tell us in the chat box. Ceramic deposited in our organs. Are you guys really curious? We are getting question marks and ceramic deposits as the answer. I'm certain it's sort of particles she inhaled. Any other guesses? I think we are getting very close to the answers. Now let's get to find out the answer. It's cobalt and cadmium poisoning. So what actually happened is cobalt and cadmium poisoning. This is a very, very, very hard click to find out, because whenever we are burning ceramics, what happens is that there are metals, sediment that are in the ceramic, which can cause complication leading to multi-organ failure, or in later stages even severe death. Early signs of all these cadmium and cobalt poisoning come out in very mild forms, such as eye pain, headaches, and even stomach burns or heart burns. So all of these are very, very, very minute symptoms, but when put together at one point will lead to a very bad effect. Let's get to the next question. This question was given to us by our seniors when we had an interactive session with them. So we wanted to include this right here because we found you guys also would be very much interested in. A couple after a long time had kids together. When they were tested for paternal and maternal genes, the genes of the baby matched, but we should notice that only the paternal genes matched, but then the maternal genes did not match. The baby was conceived and delivered normally, but the mother's genetic makeup did not match with the kid. History, there is no complication, and it was seen that it was medically stated that the child is their own. What do you guess? We are getting a clone grown inside a mother. Say if it were a clone grown inside a mother, clone is going to be obviously of your same own genetic makeup. So why does the paternal gene match and the maternal gene does not? Yes, Parvati, you got the right answer. It is because of the case called chimerism. So chimerism is a case where a person can express two different genetic makeup at the same time. Say even cases like heterochromata in our eyes, you can give them as a chimeric example. So what happens is even there are cases where they report saying even different organs have different genetic makeup. Say one of your kidney is going to be of your paternal gene, or your heart and lungs can have a different set of gene. So this is because of a condition called chimerism. We'll have to go into the next case now. Case 5, a woman has double pregnancy. So the first child was delivered, and then the second child was delivered to be 4 months from the first delivery. The woman's womb is growing properly. There are no signs of miscarriage. The first baby was delivered, and then she starts menstruating while the baby is while the other baby is still inside the uterus. There's no medical history or no medical complications previously. There's no medical complications that she had previously. Lifestyle, she's a working mother. Do you guys have any guesses what this might be? Any guesses, guys? Any weird guesses? Yes, Arjunana, you are right. Let's get into the answer. So the thing, what happened is she had two separate uteruses. Yes, she had two uteruses. So this condition is called uterus didelphys, where a person has two uteruses. Also, this is also a very rare case. So what happens is she got pregnant in one uterus for the first time, and then later she got pregnant in the second uterus. So after delivering one baby, she started menstruating in the other uterus. But cases like this happening is going to be very, very, very rare one, because there are going to be very hormonal imbalances that occur due to all of these cases. But then carrying both the baby to the term will be a very difficult condition for people with uterus didelphys. Let's get into the next question. So a 32-year-old Russian woman noticed a lump moving from her right upper lip from a series of selfies. So what happens here is this Russian woman, she's taking selfies, but then she's noticing like one small lump is there from a left eye, and it started moving from her left lip, upper lip. So she's able to see this when she's finding a view of selfies. So what happens is she's visited Moscow frequently and was bitten by mosquitoes. So Moscow and mosquitoes will be the clue here. Do you guys have any guesses what this might be? Any guesses, guys? You can tell us in the chat box. I think we'll have to find out the answer. So this condition is because of an infection. Yes, Priyadarshini, it is an infection. It is an infection by a worm called Difloria repens. So what happens is this worm is spread through mosquitoes. These are very, very, very tiny worms. So they start, start living in predating on the host tissues for energy. And they start growing at a very rapid rate when they find a perfect host. So what happens is this worm started living under the tissue of the skin, and then it started spreading under, it started spreading, like growing out. Okay, let's go to the next.
Wow, Adityan, we are mind blown with these case studies. We were able to learn a lot of new medical conditions. It was interesting. Next up, we have Jayashree to introduce our next speaker.
Good evening, everyone. I feel elated to take this opportunity on behalf of the entire Department of Bioengineering to introduce Dr. Joseph Theodore from Kaveri Hospital, Trichy. He is a renowned interventional cardiologist and electrophysiologist who holds several degrees in various range of fields such as cardiology, diabetology, and electrophysiology. Having worked in high-volume centers under eminent and dedicated professors for the last 10 years, he demonstrates knowledge and ability to share his skills. His area of specialization include pacemaker implantation, angioplasty, and rotablation. He has actively been involved in research and has presented numerous papers including role of antioxidants in atherosclerotic vascular disease. He was awarded the Sambasivara Gold Medal for Microbiology, Indian Association of Psychiatrists Medal, and has won many awards for presenting his research on prevention of diabetes. Sir, on behalf of the entire BEATS Association, it is our immense pleasure to welcome you to BEST 2021. We are delighted to have you as our speaker today.
Can you hear me? Can you hear me?
Yes, sir.
Thank you, Jayashree. It's indeed a pleasure to meet all of you. I thank the organizers of BEST for giving this opportunity. It is like after a very long time, I'm meeting a non-medical group of students a bit. Okay, so the topic which was lent to me was technology meets cardiology. Okay, so the agenda would be what are the use of technology in the diagnosis and diagnosis of cardiac diseases, and how do you use technology for therapeutics of this cardiac diseases, and how do you use them for carrying up of cardiac patients and follow up of these patients. So that is the predominant agenda of this topic. So some of these may not be there might be a mixed audience in this group. So I would always, as my professor says, okay, we will try to go step by step so that at least most of you would get at least 2 or 3 points to take home from this talk. So to start, okay, I would start with this slide, okay, to say how do you define heart? Okay, so most of us know heart is a pumping machine. Okay, it's just like a water motor pump which is irrigating a paddy field. Heart is going to just like it's going to pump water to the irrigating fields. Heart is going to pump blood into the different organs, and it takes oxygen and nutrients to the other organs. So this is a simple definition, isn't it? So, but when you really look at heart is just not a pumping system. Okay, it's a bioelectronic pumping system. Okay, this slide will tell you heart has got a muscle, okay, which has got some kind of a electrical tissue across. There is a sinus node, and from the sinus node is like a battery. From that battery, you get lots of conduction tissue, commonly called as wires. These wires take the electrical conduction and transmit across to different parts of the heart and make the heart pump. So this is the basic definition of heart. So if you want to compare it to the pacemaker, it is like a battery which is in the battery there, which is kept in the pocket, okay, in the chest, and the wire which goes inside the heart. So this gives the electrical energy. So electrical energy is getting converted into a mechanical energy of pumping. So that is the basic definition of heart. So bioelectronic pumping system. If somebody asks you what is the definition of the heart, you can simply say it is a bioelectronic pumping system. So these are the wires which I'm talking about. There is a SA node, and following which there is an AB node, and there are multiple wires across the right and left side of the heart, which takes the electrical energy and converts it into a mechanical energy. And as you know more than me, electrical energy also generates magnetic force. So I'm telling you this because at a later point of time, I'm going to bring you some concept of magnetocardiography also. So once we know that it is both a pumping system and also there is an electrical system in the heart, we need to record them. Okay, we need to record them. So we use something called as electrocardiogram. Okay, we attach leads across the heart, okay, leads across the chest, and try to record the electrical activity of the heart. But at the same time, when you put the electrode catheter, when you put electrodes inside the heart, what you get is called as EGM. Okay, so this difference you need to know. ECG is electrodes which are placed outside the heart or in the chest, okay, basically externally, and EGM is something which electrode is placed inside the heart. So that is going to be a little more sharper. Okay, so these definitions will be useful at a later point of time when we go forward. So apart from for the electrical system, you're going to record the ECG or the EGM. For the pumping system, you're going to use echo. Echo is going to show you how the right heart and the left heart are going to pump, okay, and how are you going to quantify the pumping, and all those things are going to be useful by doing an echocardiogram. So, and also we know that heart also heart's primary function is to supply blood to the different organs. It also has its own blood supply. Okay, so these are the blood vessels which are found in the heart. Okay, so which supplies blood vessels to the heart muscles. So this is the vessel which gets blocked during your heart attack. So that is what happens here also. So slowly fat gets deposited from the younger age. When you reach the 4th decade, there might be a considerable deposition which might lead to erosion and can lead to heart attack at a later point of time. So the myth is your deposition starts even from when you're at the home. Okay, it's not when you start at 40 years of age. That is what, so lifestyle modifications have to be done right from the beginning of your younger days. Okay, so how do you record the electrical activity? This is what I was saying. Electrode placed across the chest records the electrical activity. That is ECG. Okay, when electrodes are placed inside the heart, what you get is EGM. Okay, so and ECG is going to look like this. Okay, so this much is this is the echo which you are going to record. You could see the pumping of the heart here very well. Okay, so this is for recording the pumping. If there is going to be any defect, all those things are going to be seen by echocardiogram. Okay, and blood flow across the heart is going to be seen by this echocardiogram. So coming back, this is the basic knowledge with which we need to start go into the topic of today. Okay, technology. So you could see in 2000, okay, you had this Nokia phone, and 2021 you got the smartphones with every one of you. So as such, even the technology has improved in technology has got into greater depths in cardiology also. So this is the first ECG machine, okay, which Einthoven used. You could see a person who's been taking an ECG. He keeps his hand inside the water, puts his leg for grounding. It used to be so big like this. But what really happened with ages, ECG has got shrunken, and it has now gone into a state where it is like a very small chip which can be placed and ECG can be recorded. Okay, and with this technology, you are going to even see that there is going to be you can sit at home and also monitor a patient's vitals at in the CCU, from the CCU. So this technology has helped cardiologists like us to ease our work and also make our work more and more effective towards our patients. And in 2021, you can even connect it to your Android phone, get an ECG of your connect the electrodes to the Android phone and get the ECG from there. And more importantly, now artificial intelligence has come. Even your Apple Watch can record your ECGs, but it cannot be used totally for a diagnostic purpose. It can be only used for just for the rhythm abnormalities which you can see. So again, artificial intelligence in echo, you could see here. Okay, here I need not even do an echo. This is one of the echo which we have done recently. Okay, artificial intelligence is going to trace me the border and give me the function of the heart just by looking at it. Okay, so I just need to keep the probe on the patient's chest. So it's going to give me the total value of the total function of the heart by using the echo. So coming back, that is about the echo part of it. Coming into the blood vessels, which I was telling you before earlier, blood vessels are taking blood to the organs also and also to the heart. So this is a usual coronary angiogram which you see always. Okay, which a cardiologist after doing an angiography will show it to you. This is just injection of the dye which opacifies all your blood vessels and is going to give you the picture of the blood vessels. So now what has technology given us is you could put a OCT, that is optical coherence tomography. This is nothing but the infrared camera inside the blood vessels, and you could see what is really happening inside the blood vessels. So here you could see different varieties of rupture inside the blood vessels or any kind of heart attack, whether it is a red plaque or a WBC or a white clot, RBC clot. All those things can be made by using this infrared camera. Okay, so coming back to again coronary angiogram, you could see whenever you have an angiogram like this, you could see there is a block here. If you could see my pointer, there's a tight block here. As soon as the cardiologist is going to see this, he's going to stent this part, okay, and make the block improve the block here. But there might be places where the block may not be severe. Okay, that is, it might be less than 70%. So in this kind of cases, it is going to be called that as a borderline lesion. If there is a borderline lesion, what are you going to do? You need to assess the hemodynamic significance of that block. Basically, the blood vessels supplying distal to the block, the blood going distal to the block, is it whether it is good enough to supply the heart tissue there. Okay, for that, what we got, the technology has given us this FFR, fractional flow reserve. This is a pressure wire which you put across the block and see what is the pressure difference between the after the block and before the block. Okay, it is like this PD and PA we measure by using this FFR. If your PD by PA is going to be less than 0.8, then it is going to be a significant block, and you're going to use this for stenting the patient. If it is going to be significant, you're going to stent the patient. So technology has given us a gadget to assess the borderline lesion, whether you need to stent a patient or take the patient for bypass or not. The next, there are multiple ways of stenting. The usual conventional way is taking a balloon, then taking a stent. But when there is going to be a difference of what you call difficult lesion, where you cannot, hard lesion where you cannot cross, you can use laser, your light energy, for breaking that clot and taking your stent across. So this is laser which is being used for angioplasty. And now there is robotic assisted PCI, that is angioplasty, which are being done, where you just need to set in your computers at what rate and what level you need to inflate the balloon, take the stent and everything. All the things will be done by a knob which you keep it outside your cath lab. So fluoroscopy can be reduced. All the things will be done by this robo assisted PCI. So coming back, this is about the blood, the blood vessels which are getting blocked. Okay, how do you treat it? How do you use technology to treat it? The next thing is, what I was talking about is electrical part, the electrical activity of the heart. So here what you see is an ECG. I told you already there was an ECG before. Okay, that was a normal ECG. Here what you see in an ECG is an heart rate of 200. You could see each and every beat of this is very fast. So it is a heart rate of around 200. As I was telling you, heart is an electromechanical pumping system. So heart has to pump at a rate of 60 to 100 beats per minute. When there is going to be extra, it is going to be going at a faster rate, that is 200 beats per minute, it means there is going to be an extra circuit in the heart. If there is going to be an extra electrical circuit, you need to find the circuit and try to terminate that circuit, or else you're going to develop, your heart is going to get weaker, or this extra circuit might even kill a patient. So what has technology given us? That is what I was telling you about the EGM. Okay, you can take your electrode catheter, okay, and this electrode catheter can be placed inside the heart, okay, and you can record electrical activity, what is happening inside the heart, by using this electrode catheter. These are the catheters which has this electrode at the tip. Okay, you could see there are 4 electrodes here, and this will be connected to our electrophysiological system. Okay, and this can be used for, this is how we place this catheter inside the heart. Okay, and we will use this electrodes to record the electrical activity. Then, okay, it can be just 4 electrodes like this. You could see 1, 2, 3, and 4 electrodes here, or it can be electrodes which can be multipolar electrodes, something like this. This is called as high definition electrodes. Here, what we have is something called as a magnetic sensor. Magnetic sensor will tell you which part of the heart you're taking this electrode catheter, and will be able to map the exact geometry using the electrical activity of the heart. So when you take this catheter for the same patient, you can map the electrical activity of the heart, give a complete map of the electrical activity, label which part is electrically activated earlier and which part is electrically activated later. So here in this map, you could see that whichever is red, okay, is activated earlier. Whichever is blue is activated later. So this is an annotation which will be given, okay, by using this electrode catheter. Okay, so red or white part, or the part which are getting activated earlier, so that the electrical circuit starts at that point. So if you go and terminate or burn that place inside the heart, you are going to terminate the tachycardia or the circuit there, and you are going to prevent the patient from having this tachycardia. That is a higher rate which I was talking about. So here it is around this part, and when you use this electrode catheter and given energy, okay, that is thermal energy, you're going to burn the tissue and burn the circuit there. So this is other thing. Okay, this is what I was talking to you earlier. This ECG, EKG, or of for the present, okay, the future is going to be magnetocardiogram. Okay, as I was telling you earlier, electrical energy is going to also generate a magnetic energy. You know me, you know this better than me. Okay, so this is going to be a magnetic energy which is being generated in the heart by this electrical circuit, is going to be very, very meager. So you're going to use this magnetic energy and try to map what kind of magnetic activity is happening in the heart. This can be used later for studying a normal arts and also for using diseased arts. So, but in Earth is a big magnetic field. So you need to separate that magnetic field from the small current, magnetic current of the which is happening in a person. So for that, what he uses this kind of magnetocardiogram, where a patient lies inside a magnetocardiogram room, and you use this MRI kind of a machine, magnetic kind of machine, to record the magnetic activity of the heart, and which will give you a similar picture like your ECG, okay, a tracing like your ECG. And this will be differing between a normal heart and diseased heart. That is going to be a kind of a research which we need to further take on, and as young minds, which you need to take on. So as I was telling you earlier also, once if there is an electrical block, you're going to go and put a pacemaker. Okay, this is a pacemaker box which is being kept in the chest, and the wires are going inside the heart. Okay, this is one of our patient. Okay, but when you put these kind of pacemakers, what really happens is you keep a big, large wire inside the heart. Okay, but what has really happened is if you put it in small kids don't have a custom-made pacemakers, so that can get eroded like this. Okay, this is one of our patient which got multiple erosion of pacemaker, but the patient was totally dependent on the pacemaker, because without the pacemaker the patient will die. So in this patient, we took this patient, okay, because this, you could see this, these are the pacemakers which have been miniatured throughout the decades. It was this big, and now it has come to this size. Even this battery is not going to be fit for a children. Okay, so in this kid who was getting more and more this device related erosion, what we did was put a leadless pacemaker. This is a small pacemaker which has been hanging inside the heart, which you could see here, a small pacemaker, a chip like pacemaker which has been put inside. So when compared to this pacemaker, okay, you could see how big this pacemaker is, taking wires inside the heart. Look at this pacemaker. Okay, this pacemaker is a small capsule kind of thing which is being kept in the heart, and will take and will use and will provide the pacemaker function for the heart. So again, there has been artificial heart which has come into the picture, where the artificial heart can be just inserted into the heart in weaker patients, and can be used for pumping blood from which is being received in the heart inside the for two different organs inside the body. So this is a picture which you could see it has come in the side of almost to the size of a palm here. This is an artificial heart which was implanted in one of our patient maybe 2 years before. Okay, so again, for follow-up and care of the patient, many of this patient, for maybe follow-up for pacemakers or something, they can do it with a remote monitoring system. Okay, all these things are Wi-Fi enabled. They can just place it over the pacemaker, and those information can be transmitted to a doctor's room, and we can use it for analyzing whether the pacemaker is functioning well or not in this patient. And thanks to the COVID era, now we have been using all this video and telecom consultation, so that technology has come in greater use for treating and follow-up of the patients. So take home of this talk would be, technology has eased and improved cardiology care. Okay, so that we are giving good quality, and we are using it for the better improvement of the many patients, and even it is getting us prepared to post-COVID era. And technology is going to improve much and much. Okay, and there is going to be many more things which are going to come by younger minds like you, and we are going to use it for treating our patients and improving their outcome. So before I finish, being a students, I will always incite 2 research questions to you. Okay, so these are 2 research questions which you can always work on as a biotechnology students or something. So when I was talking about pacemakers, nowadays when pacemaker life, that is the battery has a longevity for 5 years, 10 years or something like that. Once the battery reaches its longevity, that is the battery drains out, you need to again take out the battery and put a new battery. Okay, you guys, okay, should work on something like a rechargeable pacemaker battery. Okay, something like just like we recharge our cell phones, you can just place something like on the pacemaker so that it can recharge the battery of that without needing to reoperate on the patient. And as I was telling you earlier, magnetocardiogram is a very important diagnostic tool which is going to rule for the next 20 to 30 years of the cardiology field. So as younger minds, you should concentrate on this. Magnetocardiogram is available in Kalpakkam Atomic Research Center, Baba Atomic Research Center, but is still being used only for research purposes. Okay, so you should really use projects, okay, to bring it out into the clinical purposes. So I'll conclude by saying this: success doesn't come easily. Okay, it consists of going from one failure to another failure without loss of enthusiasm. Thank you. I'll be open to any questions.
Thank you, sir, for your wonderful speech. We have some questions in the chat box.
Yeah. Can you read it out?
Yeah. Would increasing batteries in pacemaker increase its longevity?
Increasing?
Increase its longevity.
Increasing the battery size, you mean?
Increasing batteries in case.
Yeah. The more and more battery, now the pacemakers, what we have is lithium iodide vanadium batteries. Okay. We have been using lots of different variety of metals for batteries and for usage of batteries in pacemakers. But what really has happened is, at last we have zoomed in on lithium silver iodine battery. But the more and more battery you use, the pacemaker size is going to get bigger and bigger. Okay, so if you're going to use larger batteries, the pacemaker size is going to get bigger. So that is not going to be useful. Then you'll have to use, as I was telling you, I was giving an example of a child also. For child, you cannot be using a pacemaker at all. Okay, so you should try to decrease the battery size, but at the same time make it more and more efficient so that the longevity improves.
Thank you, sir. Next question is, how the miniatured version of pacemaker helped the child? But should the surgery be done again as the patient grows older?
Yeah, basically, the child was having, okay, recurrent erosion of the pacemaker, normal adult pacemaker. Okay, the size of the pacemaker was too big for a child's chest. So that is the reason why the child was having recurrent erosion. So once you have these kind of erosion, you cannot keep on putting the pacemaker. At some point of time, it might get infected and might cause infection inside the heart. So that might become very deadly to the patient. So this miniature pacemaker is something like, okay, something like a small capsule where you go through your leg veins and place it inside the right ventricular apex. Okay, it's like a tine. Okay, it has got some screws at the end of its capsule, and it is also a battery. Okay, and the tines are like your pacemaker leads, so it will hang on to that heart muscle, and it will give you a pacemaker function there. Okay, so it will pace the heart, pace the heart, and again the longevity of those kind of pacemakers also is around 8 to 10 years.
Thank you, sir. Next question. What do you do when you have to analyze a MRI for a pacemaker implemented patient?
Yeah, fine. This is a question which I think many people keep asking. Okay, when you really look at the literature, okay, do you think there is lots of worry about, okay, MRI being done on a pacemaker patient? Okay, but I tell you for sure, okay, the MRI can be done on any pacemaker patient. Okay, take me pre-it. Okay, this is something which when I was working as an associate professor in cardiology in JICMER, we have worked out on multiple research projects also. Okay, so this is like MRI can be used even on pacemaker patients. So there has been a myth that MRI might slightly eat the pacemaker wires and can cause the pacemaker to fail. But there has been lots of studies, okay, which has been proven that it happens in very, 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 what you call 0.00001% of any patient. Okay, and other thing which I want to tell you is, market has driven it as if that one single complication which is happening in 10 crore patients. Out of 10 crore patients, pacemaker patients, if you do it on one patient might develop a small nugget. They will blow it to such an extent that pacemakers cannot be done on an MRI cannot be done on a pacemaker patient. But still, what really happens is it can be safely done on any pacemaker patients. And only thing which you need to check is you need to go and check the the parameters before and after the MRI which is being done. The only rider is do not do MRI if the pacemaker is implanted less than 30 days from implantation. That is the only rider. Apart from that, if MRI is required in a pacemaker, you can go ahead and do it.
Thank you, sir. Next question is, what's your recommendation towards usage of solar batteries?
What? Solar batteries?
What's your recommendation towards usage of solar batteries?
Yeah, that I think you guys have to work on it. Okay, so solar batteries, I'm not sure whether it can be very easily used here, but that's a very interesting question. I should congratulate a person who has asked this. Okay, I want young people like you to think like this. Okay, so it's an interesting thought. Okay, so you can think on it. You can always meet me sometime. We can work on it also. Okay.
Sure, sir. Next question. Can we design a pacemaker which can be recharged by using wireless charging method?
Yeah, that is what I was trying to tell you at the end of my talk. Okay, these kind of things, okay, are going to be the game changers. This is where a technology is going to help people, okay, help clinicians give better results to their patients. Okay, once battery gets drained, okay, every time, okay, I need to go in and operate on the patient. Okay, so as a clinician, I would want, and as a patient also, it doesn't really need reoperation all the time. It can be done. Okay, this recharging battery can be done, but somehow because of pacemaker company, there is lots of millions of dollars which are involved in this. Okay, that is why they do not want these rechargeable things to come up in future. Okay, but if you young minds can work on this, the Indian patent for this research question is with me. Okay, so if you really want to work on it, we can always work on this. So it's still not available. Rechargeable pacemaker batteries are not available. It should be. It can be done. Okay, you need to develop a circuit which can be very easily recharged by keeping just a rechargeable thing on the pacemaker on the chest. If it can be done, you're going to win the Nobel Prize next time.
Thank you, sir. Next question.
Yeah.
You have mentioned about borderline lesion.
Yeah.
In case the condition is not serious, what would be the action, sir? Would the patient still be treated or just cautioned about the condition?
Borderline lesion is whenever we have more than 70% block, it's called as stentable lesions or significant lesion. Okay, when it is between 50 to 70% of 70%, it is called as borderline lesion. Less than 50% is non-obstructive lesion. That is, it doesn't cause decreased blood flow across that lesion. Okay, so it is non-significant. So 50 to 70% is the borderline lesion, but whether that causes decreased blood flow across cannot be just looked at by your angiogram and can be defined. Okay, so it has to be scientifically proved by doing this FFR. That is what I was mentioning about this FFR, which has been provided by your technology. Okay, we will put a wire across this borderline lesion, find the pressure difference between the blockages. Okay, the proximal to the blockage and distal to the blockage. If there is going to be less than, the ratio is going to be less than 0.8, then it is a significant lesion. So this significant lesion has to be stented. If it is non-significant lesion, patient needs to be only on medical management. There is no need to put a extra metal or extra stent inside his coronary arteries. That is what I want to mean. So then it is called as borderline lesion, but still the patient will be on medications, but not on stenting, or should not be taken for stenting or bypass.
Thank you, sir. One last question. How is electrophysiology used in clinical setup?
Oh, fine. That is what I was telling you. My entire slide was on that. Okay. Electrophysiology is something like a chess game. Okay. It's like knowing where the circuit lies inside your heart. Okay. It has come into vogue almost for now 20 years. Okay. I've been practicing electrophysiology for 5 years now. Okay. So it has been into clinical practice by whenever you want to treat a patient who has bradycardia, whenever you want to treat a patient with tachycardia, the best treatment would be offered by an electrophysiologist and not by a cardiologist. Okay. So electrophysiologist looks at the mechanism why this happens, puts this electrocatheter inside the heart, find where the circuit is there, and that circuit can be burnt by giving your radiofrequency ablation. That is what I was telling. This radiofrequency current will be transmitted into electrical energy, thermal energy, and will burn that circuit. If there is going to be a tachycardia, there is a circuit. That circuit needs to be burnt by doing an RFA. Okay, that is radiofrequency ablation. So electrophysiologist does it, and it has been in work for 20 years. Okay, if there is one field in cardiology which gives cure, okay, cure which I mean is which completely cures the patient, that is electrophysiology. Why? If a patient has a heart block, that is blood vessel block, you're taking out the disease, giving him a new stent, that is a new disease. Okay, but electrophysiologist will go and try to treat the circuit and cure the circuit. Okay, so you're treating the circuit and curing the circuit. Okay, so it is not taking a new old disease and putting a new disease. Okay, so there are only few fields, okay, in cardiology or all of medicine which can cure a patient. Okay, so electrophysiology is one such field, subspecialty of cardiology.
Thank you, sir. Your insight about technology meets cardiology present and future has given us a lot to wonder about and has piqued our interest to further venture down this field. Your simple statement about how heart is just a bioelectronic pumping system has definitely intrigued and enlightened us. It was a great privilege to have you here today. Once again, thank you, sir.
Thank you very much.
Thank you, Jayashree, and thank you, sir. Now I invite our treasurer Adityan to deliver the vote of thanks.
Good evening, everybody. Respected Vice Chancellor, Deans, Head of the Department, Honorable Speakers of the Day, and distinguished faculty members, and my dear fellow students. Gratitude makes sense of your past, brings peace today, and creates vision for tomorrow. At this juncture, it is our very honor to thank the Vice Chancellor, Dr. Vaidya Subramanian, and the university management for blessing us with such an opportunity of learning in setting up this wonderful platform, Bioelectronic Systems and Smart Technology, BEST 2021. We'd also take up this opportunity to express our gratitude to our beloved Head of the Department, Dean Shash, Dr. K. Uma Maheshwari, for providing us with the guidance and support in setting this wonderful platform of wisdom. We'd fail in our duty if we do not express our heartfelt thanks to today's distinguished speakers. It is our privilege to have heard your talks, and I believe that this knowledge will ignite young brains. We thank you again for having to shed light on the gathering today. Chisel to Excel has been always our motto of our coordinators, and Dr. Noel and Dr. Hemalata, we are indebted to you for being the backbone and encouraging us throughout this organization of this seminar. We'd also like to mention our sincere thanks to staff coordinators, technicians, and every single contributors who made this event a grand success. I'd also like to thank my faculties, Dr. Chandra Mohan, Dr. Noel, Mr. Celestin Jaral, Dr. Hemalata for keeping and mentoring us throughout. I'd also like to thank my seniors Arjun, Shruti, Purnima, Harshini, Arshita, Gopika, Ramachandran, Raghav, and my fellow batchmates Swati, Shadiha, Subiksha, and Lasha, who've been behind screens helping us to make this national seminar a valuable learning experience. Finally, I express my gratitude to the fellow organizers, participants, and everyone who helped us shaping this day into a valuable learning experience. Thank you all.
Thank you, Adityan. Now I invite Dr. Hemalata to address the gathering.
Ma'am, you're on mute, ma'am.
Thank you, Arjun, for reminding me. And good evening, all. And I take this to be a very great opportunity to extend my vote of thanks and also my gratitude to my fellow members and also my student community. Right from the scratch, the management, our dean, our Dr. K. Uma Maheshwari ma'am, and to put a feather over it, Dr. S. Swaminathan sir, Dean PD, and above all our faculty members have extended their heartfelt cooperation towards the successful completion of this particular national level seminar. And has been one of the student member of BEATS and also a faculty member of BEATS. This is a extremely mind-throbbing event for me as such. And to show a few words, Adityan has entirely covered all notes about gratitude, and I wish to put a few notes about their cooperation. It's easy to conduct a offline session of seminar or whatever it is. We meet people, we request them, and we also have we request them to come on stage and present something. But this is a virtual forum where we haven't met people for nearly a year or something for past 3 semesters. And despite of all these discrepancies, the student coordinator Adityan, his seniors guided by Shruti, Gopika, Arjun, and Ramachandran, and his colleagues as well as his juniors have put a great lot effort in planning and also scheduling and arranging all our speakers to make this event a grand success. So on behalf of the faculty fraternity, I extend my heartfelt thanks and also my sincere gratitude for your cooperation and for your higher end disciplined behavior during the entire session of presentations. And I extend my gratitude to the speakers who have spent their valuable time despite of their busy schedule to deliver and shower their ideas to our young budding engineers. So thank you one and all for making this event a grand success. And a special note of thanks to Dr. K. Uma Maheshwari ma'am for always being a backbone for this, and Dr. Chandramohan sir for mentoring us on this entire proper conduct of all the events. So thank you, sir, and Dr. Dakshinamurthy sir also for arranging speakers towards the critical situations. So it's really a wonderful event to spend time with you all students, and thank you one and all. Thank you.
Thank you, ma'am.
I must add actually, Swati, just a minute. I was enjoying the whole day, though I was not visible. But I think I never thought you have exceeded expectations, I should say. There was not a dull moment. There were a lot of information. And even if we tune in at any point of time, you know, we could get a lot of insights. And some of them have been really very, very interesting. You know, the facts, something that I have not heard before. I'm sure all the participants would feel so. There had luckily been very, very minimal technology glitches, all of thanks to also our IT support. And all of you had done impeccably well. I should really congratulate this. I think this has been a terrific experience and probably new beginnings. Maybe your juniors will find it very difficult to emulate you, but I'm sure the second years who are listening would already be making plans to see how they could improve the benchmark that you have set, and you have really set the bar very high. Congrats to all of you.
Thank you for your kind words, ma'am. I would also like to say this. Thank you, Hema ma'am, and thank you, Noel sir, our faculty coordinators. You have been our greatest support and helped us in every way possible.
I thank everyone who attended the conference and made this a huge success. Please do give your valuable suggestions via the feedback form posted in the YouTube comment section. Certificates will be presented to you once you fill in the form. We hope to meet you all with yet another wonderful session. Keep track of your emails to receive the InVivo magazine released by our Beats Association for free. Stay safe and thank you.